Hello everyone, I'm audible. Okay, so fine guys, good morning, good afternoon, good evening. So let's start. I have Blue Manual. I really wanted to show you for sure after this class so we can discuss at the end of this class. Good afternoon, I just have a small question. I'm about to complete my post project. If I have a demo my project, whom I should reach out to, should I be Skype? Just drop a mail to query. So I think they will allocate it. Yeah. So okay, so next week we need a holiday on account of the Pavli celebration. Yeah, I know it's a festival time, right? So we all need some sort of holiday, but we have to discuss so many things at the same point of a time. So I believe let's discuss about it and then we'll decide. So when we can have a holiday. Okay. So fine, guys, let me share my screen. We got a mail for a resume discussion. Is there any time? I have not drafted one yet. So yeah, you guys can start doing your resume discussion with our team anytime. So that's the reason. So we have sent you a mail. And yeah, so soon we will start talking about a project back to back. Because there are a few topics which is left. So once it will be done, so I think you can start your resume discussion. Those who are going in fast track, just go ahead with your resume discussion with our team. Okay, so fine guys, let me share my screen first of all. Okay, so I believe my screen is visible. Yeah, okay. Fine. Any mock interview at the end of the course, even in between. So if you would like to schedule a mock interview with our team, you can go ahead with that. Right. So just drop a mail saying that I want mock interviews. So from our side, person will be allocated. They will take your mock interview and they will try to evaluate you that how you are and in which area you are lagging. And based out of that, so I think you can do a preparation. So yeah. Yes, sir. 2 lakh रुपया कैसे जीते सर? क्रिस सर ने प्रोजेक्ट दिया है. Yeah, so that is a project defined by a same person who has already done that project, and I think we all know his name, right? Avnish. No, it's not an issue. I'll be talking about it. Projectathon, right? That we have launched. So at the end of today's class. So first of all, let me complete my topic. I have to complete a lot. So this is a topic I'm going to discuss first of all. Yeah. So in today's class, I'll be talking about a clustering. So first of all, we will try to understand what is clustering and why clustering is required. And before that, so we will try to understand that what is unsupervised learning, because we have seen supervised learning approach. And in case of a supervised learning approach, so your feature will be given to you. So let's suppose X1, X2, X3, X4, and so on will be given to you, and your label will be given to you. And in general, so we try to find out a relationship between all of these features with respect to a label. This is what we do in general in case of a supervised learning approach. And again, inside the supervised learning approach, so we have seen regression, we have seen classification, and that can be done with the help of multiple algorithms. Some of the algorithms we have already discussed theoretically, some of the algorithm we have discussed even practically, and some of the algorithm we are yet to discuss in terms of a practical, right? That's fine. Now, so in case of a supervised learning, what we do is, so we generally try to find out a relationship between our labels and our features. So means y and x value. So this is what we try to understand, and based on that, so algorithm will try to normalize, or algorithm will try to find out some sort of a pattern in between, and it will try to build a model, and we say that as a training, right? So this is what happens in case of a training. And at the time of a testing, what happens is, so we'll try to provide all the features, and then it will try to give me a labels, or it is going to give me y in case of supervised machine learning algorithm. Now, in case of unsupervised machine learning algorithm, what happens is, you are not supposed to give a label data at all. Your entire data will behave as a feature. or your entire data will be considered as a training purposes where labels are not given to you. There is no y value which is given to you. Then you can ask me a question that, okay, so then why we are even using it? So what we are trying to predict over there, right? If y is not given to me, or if y we are not supposed to find out, then what we are trying to predict over there? That's a question, right? So let me give you an answer in this way. So let's suppose I have a data set, maybe given in this way, right? So I have a data set given in this way. Now, so if I'll give you this particular data set, and if I'll ask you, fine, so can you please place this data set maybe in this set or maybe in this set? So what you will do? So you will try to check a similarity. So how similar this data set is with respect to this one or with respect to this one, and based on the similarity or based on the observation, so you will try to place this data set over here or maybe over here. This is what we do, right? So here I have not given you, I have not told you any kind of a outcome, the outcome wise. So what I'm expecting over here is that just try to place this particular data set in a certain groups, or even when we try to perform a grouping. So based on the similarity of the object, so it will try to keep all the object in a single places. In a layman way, if I'll try to give you an example, so we all go to a shopping mall, right? We all visit a shopping mall. So in shopping mall, so or maybe big basket, sorry, not big basket, this big bazaar, right? So we all go to a big bazaar, we all go to a shopping mall, and shopping mall, you will be able to find out like one place where they are keeping each and everything for men. Then in other places, so for women, again inside men and women section, you will be able to find out a different sections, maybe section for shoes or maybe shirts or pants or whatever it is, right? So you will be able to find out a different kind of a grouping. So let's suppose there is a salesman, right? And you have ordered a new lot of shoes, and if, or maybe like a shoes for men's, right? A formal shoes, let's suppose, again inside a shoes, so there will be a formal, informal, there are variety of things you can find out. So there is a salesman or there is a person who is working in a shopping mall. So if they will be able to get a new lot of shoes, right? If they will be able to get, so what they will do, they will try to keep it inside a section, so where this particular shoe is having some sort of a feature, matching feature with other shoes, which is been like kept over there since a long time, right? So this is what they used to do. So again, it's called as simple a grouping. So based on the similarity of the group, they will try to keep, or they will try to place a particular object in a respective location, or maybe in a respective places they will try to keep it. So again, we can say that yes, so like when suppose you are trying to do the same thing, so what you will do, you will just observe, you will try to observe a properties, right? And based on your observation, you will just try to keep it. So if our algorithms will be able to do a similar kind of a things, right? So I'm not telling you that, okay, fine, so go and keep this shoe over there. No, I'm not going to tell you. I'm not going to tell you that go and keep this particular shirt or pant in that particular section. No. So we are trying to observe. Then observation wise, what we are trying to do, we are trying to check a similarity, right? And then based on that similarity, I'll go and I'll just try to keep it over there. Everywhere it happens, right? In shopping malls, or maybe grocery store, right? So there will be a different kind of groceries they used to keep in a different places, so that it will be easy for you to find out. It's not like they will keep one packet in one corner, other packet in another corner, right? So they will try to keep everything in a single places, so that it will be easy to find out. Similarly, if my algorithm will be able to perform a similar kind of things, if they will be able to check a similarity, and if they will be able to do something like that, so we used to call that kind of a problem statement as a clustering, right? Clustering, or you can say grouping. So clustering is nothing but it's a trainable approach. Grouping is nothing but it's a if else kind of a approach. Based on that, you can try to write a program, and then it will try to do a grouping. So this is where clustering comes into picture. Now you will ask me a question that why clustering is required. Let's suppose someone has given me a data set for classification, for a regression. Then why do we need a clustering, or why do we need a grouping of the data set at any point of a time? So many of you, right? Many of you have built a model in a previous classes, classification model, regression model, right? And many of you have complained that you are not able to achieve a better accuracy, Now, if you will try to think through it, right? So what is the reason why you are not able to achieve a better accuracy with respect to those data set? Is XGBoost over? No, not at all. So we are yet to discuss that practical part and many more things. So here, so when you will try to think about it, why you are not able to achieve that kind of accuracy, so you will be able to understand, right? You will be able to understand that there are a huge variances in between a data set, right? Your data set is like a scattered from maybe one range to another range, and the difference between that range is very, very high. Now, if difference between those data set is very, very high, so it's very, very difficult for our model to generalize those data set, because classification or regression algorithm try to generalize your data set, and that is a problem. And because of that, because of like a non-generalization of the data set, your model accuracy is very, very less. And you say that I'm able to achieve only 60% or maybe only 70%. Then what is the solution? Right? Even if you are going to use XGBoost, you are going to use ensemble technique, a best of the algorithm, but still you will not be able to achieve accuracy, right? Then what is the reason behind this one? Because of variance. If variance is very, very high, for sure, you will not be able to perform or you will not be able to get an accuracy. So what we can do in that case? So what we can do is we can try to create a group of the data set with a similar kind of a variances, or which is having a similar kind of a nature. So let's suppose we are going to create group 1, we are going to create group 2, and we are going to create group 3 over here, right? So if we are going to create a multiple groups, and for this group I will try to build a model number 1. For this group, if I will be able to build a model number 2, and if for this group, if I will be able to build model number 3, right? Because in this case, accuracy of all of these models will be high, right? And this is an approach that we try to follow all the time, and it's called as semi-supervised approach. So where we are trying to use supervised as well as unsupervised machine learning algorithm, first of all, to divide a data set into a multiple groups, and then we are trying to do a training. And this is what we are going to do even in your projects. In a very first project that we are going to discuss, so we are not going to discuss directly a clustering approach or maybe classification or just a regression. So it is going to be a semi-supervised, customized machine learning approach. So where we will try to group a data set based on the nature of the data. We'll try to do a training by creating a multiple groups of the data, and then we are going to do a prediction. In that case, accuracy will be high, or best possible accuracy. I'm not saying that it will be high like a 90%. No, if there is no variance, if there is no relation, so for sure it is not going to give you a better accuracy. But yes, it will be a best one, you can say. So this is the best that you will be able to get out of the data set. So simple. Now here, so keeping these things in our mind, so clustering approach is very, very important, or this unsupervised learning approaches are very, very important. And almost in every algorithms, we try to do this kind of things always, right? So here, right, here, so what we can do is, so maybe we can try to understand this algorithm. So how this algorithm actually works, how this algorithm is going to decide, just like a salesman in a like a shopping mall, that okay, so there is a similarity between a data set, so let's place this particular data over here, or this particular t-shirt, or maybe a suit, or maybe a shoes in this particular places, just like a salesman. So how my algorithm will be able to learn a similar kind of a things, we are going to understand that over here. So hope an idea of unsupervised learning is clear to you, right? Plus idea of clustering and where we are going to use this particular approach is clear. So can I get yes or no, something from your side? People are asking that XGBoost. So XGBoost, I don't think that I have finished, right? So I thought of like completing this one, because this is a bottleneck in terms of discussing a projects, unless and until because your first project starts with the customized machine learning approach. So that's the reason. So hope this idea is clear. Okay. So now there are multiple algorithms, clustering algorithms, you all will be able to find out, right? Like k-mean clustering. Again, don't get confused with the KNN. KNN is a classification and regression algorithm, whereas k-mean is a clustering algorithm. And many people, as a beginner, right, we always gets confused between k-mean and KNN. So KNN that we have discussed, right? So that is basically a classification and regression algorithm. It's a supervised machine learning. It follows a supervised machine learning approach. Whereas K-mean, right? The very first algorithm that we are going to discuss over here is a K-mean. The second algorithm that we are going to discuss over here is hierarchical clustering. And the third algorithm that we are going to discuss over here is called as DBSCAN, right? So these three algorithms are very, very important. And at the end of the day, I'll tell you, DBSCAN is one of the most effective and a powerful algorithm, which covers a drawback of K-mean as well as a drawback of hierarchical clustering. And it will always give you a robust result as compared to these two algorithms. But yes, it's not like you are not supposed to use this algorithm. You are supposed to use all of these, depends upon a kind of a system that you are trying to build or kind of a data set that you have. So fine, we have discussed that. Okay, fine. So in case of an unsupervised machine learning approach, there will be like all the data set will be considered as a feature, right? It is just supposed to create a groups. So if it is able to create a groups, my work is done and I will be happy. I will be able to perform all sort of things, right? So here, right? So here again, in this way, you will be able to stop an overfitting as well, overfitting of the model as well. Like I told you, so by using a customized machine learning approach, it gives an strength to your model, right? By creating a multi-model for a single system, right? It gives you a strength to give you a better prediction at any point of a time. And based on this same theme, project is available to all of you. Okay, so now let's try to understand a K-mean algorithm. So how this very first and a basic algorithm of a clustering is going to work for us. Idea is again simple. So multiple objects are given to you or multiple data points are given to you. And if some new data points comes into a picture, so it is supposed to take a decision that new data points will go in this side or maybe on this particular side. That is the whole idea, which is which we are supposed to prove and which we are supposed to implement at any point of a time. Now, if I'm talking about an application of a clustering, so there are so many applications you will be able to find out in terms of clustering, right? So I have given you this salesman example, right? Plus, if you are looking for a customer segmentation or maybe a grouping of a resumes, right? Grouping of a profiles or grouping of a similar kind of events, right? Everywhere. So these kind of algorithms or clustering based algorithm can be used in many more cases. So there are almost every machine learning algorithm where you can try to implement this clustering approach at any point of a time for the betterment of and robustness of the algorithm. So here, if I'm looking for customer segmentation, right? So here you can use like a clustering algorithm, clustering approach, any of these three. So K-mean, HC, or maybe a DBSCAN. If you are doing some sort of a data analysis, so maybe cluster-wise data analysis you can try to do, right? So even in like a data analysis, you can try to use it. Now, the third number is if you are looking for some sort of a outlier detection, and we say that as a anomaly detection, right? So in terms of outlier detection, how we are going to use it, we'll discuss. But yeah, so if I'm looking for some sort of an outlier, a kind of a data set which is out of the group, so again in that case I can try to use a dimensional reduction technique. So anomaly detection, we can try to use this kind of a technique, right? Let's suppose if I'm talking about a search engine, so how Google is going to work or how Google is going to store a data set. So for sure, based on a similarity, so they are trying to store the data set. So again, for a search engine optimization, we can try to use this particular one. Then if I'm looking for a segmentation of a speech or maybe images, segmentation, so we can try to use it. So we can try to use this kind of things for multiple purposes. Even when a bank person is going to call you for a credit card or maybe for a home loan or maybe for a car loan or maybe some sort of an insurance product, when they try to sell you, So they try to segment different customers. This is what I have mentioned in point number 1, customer segmentation. So they try to cluster, or they try to create a groups of a different customers based on the similarity of a customer's records, maybe a kind of expenses that you are going to do, or maybe a kind of a like a number of payments that you are doing through a credit card, or through a debit card, through a net banking, or maybe through some other medium, kind of a things that you are going to purchase, kind of an income that you have, kind of a saving that you have. So based on that, so they will try to create a segment of a different customers, and they try to offer you a different kind of a card, different kind of a credit card, or maybe different kind of a policies, or maybe a loans they try to offer you. So this is what happens in general. Again, so we all used to see a different ads, right, over a YouTube, or maybe over a mail, or maybe in some other website. So again, over here, so it will keep on creating a groups of a customers, and for those groups of the customer, they try to target. So those groups of the customer will be created, or if there is some new customer, so it will be added inside a particular or respective groups based on the similarity, or based on the properties. So this is the only thing that happens in case of a clustering. So based on the similarity, so they will try to keep on adding all of those things into a particular groups that we used to call as a clusters. So how this very first algorithm, a k-mean clustering, is going to work, so let's try to understand. It's very easy. It's very easy to understand this particular algorithm. So I'll try to give you one simple example over here, right? So let's suppose there is a data points which is given to me. So these are the data points, and let's suppose this data set is available in 2 dimensions. So for sure we have a x1 and x2 coordinate. So let's suppose this is a x1 axis and this is a x2 axis, right, which is representing this entire data set, right? So here what will happen is, so let's suppose I have to create a group. I have to create a group inside this data set, right? So let's suppose if I would like to create a groups of this entire data set. So what will happen, and how it will be able to create a groups, or how k-mean algorithm is going to work or behave. So what k-mean algorithm does is that it will first of all try to find out a value of, or optimal value of a k, right? So in case of knn, we were trying to find out the value of k. In case of a k-mean, again we try to find out the value of k. But the way by which we try to find out a value of k is actually different, and as compared to a value of a k that we were trying to find out in case of a knn. So in case of a k-mean algorithm, we try to find out a value of k by using an approach called as WCSS, within cluster summation of square. Now, what is this WCSS and how it is going to work? So let's try to understand. So what k-mean algorithm does is, so let's suppose you have given this data set and you are asking an algorithm to create maybe a groups, or divide this entire data set in a groups, right? So there is a possibility that algorithm may divide your data set into 2 groups. There is a possibility that algorithm may divide your data set into 3 groups, right? Maybe into 4 groups, maybe into 10 groups, maybe into n number of groups, where n is nothing but a number of data set which I have given to this particular algorithm. So that means number of the groups that we will be able to create. But how many number of groups we are supposed to create, how we will get to know? What is the optimal number of the groups which I will be able to create? Because if you are going to create n number of groups, where n is a total number of records which is given to you, right? So in that case, what is the meaning of doing a clustering? Because individual data points will behave as a whole data set in that case, right? So there is no meaning of creating n number of clusters over here. But yeah, so there is a chances that if I will be able to create, let's suppose just 2 groups over here, these 2 groups over here, and then if I'll try to perform something for this group and something for this group, maybe I will be able to get a better result. But how it will get to know that I have to create a 2 groups, or maybe a 5 groups, or maybe a 10 groups, right? So this is where we try to find out a value of a k, and this is where its names comes from, called as k-mean algorithm. So let's try to understand how I will be able to build a k-mean algorithm, or how k-mean algorithm will be able to build these things. So what k-mean algorithm does over here is, so k-mean algorithm, let's suppose hypothetically I'm going to keep value of k is equal to 2 as of now. right? I don't know whether this is a correct value or whether this is the incorrect value. I've just taken value of k is equal to 2, then I'll take 3, then 4, then 5, and so on. So as of now, I have considered a value of k is equal to 2, and I will try to run an experiment over here. I'll try to run an experiment over here. So what is the meaning of like a keeping value of k is equal to 2? So k is equal to 2 simply means that I will try to draw maybe 2 points, random points, right? So this is the meaning of value of k is equal to 2. So 2 random points I have taken, just 2 random points. So let's suppose here is my data set x1 and x2, and all these things is been represented by all this circle. So hope you all understand this graph, meaning of this graph with respect to x1 and x2. So here, let's suppose if I have taken these 2 points over here, this is the meaning of k is equal to 2. K is equal to 3 means 3 points. K is equal to 4 means 4 random points. K is equal to 5 means 5 random points, and so on. So I will try to take a 2 value of a k, right? I'll try to take a 2 value of a k over here, right? Or 2 points I will try to take over here. And anyone who can tell me what is a centroid of the point? So I think we all understand a centroid, right? Yeah. So can I say what will be the like a centroid of this one dot? So let's suppose if I'm talking about this point. So what is the centroid of this one? So can I say that centroid of this point will be a point itself? Yes. Yeah. So it's a point itself, right? What is the centroid of human body? So can I say that we have a centroid, right? So like is nothing. So we have a centroid. Yes. So centroid is nothing but a place from where you will be able to balance any kind of an object on a needle, right? There's something called a centroid. So for every object which exists on this planet, so for sure you will be able to find out a centroid. So let's suppose if I'm able to balance this pen on this tip, right? So fingertip, so it's a centroid of this particular pen. Simple. So here, let's try to understand this part. So we have taken k is equal to 2. It simply means that 2 centroid I have chosen, right? Randomly. I don't know about its coordinate. I don't know about its location, right? So 2 points I have chosen. Now, what I will do with this particular points? So first of all, what I will do is, so I will try to find out, I'll try to check, okay, fine. So this and these 2 points are near to each other, right? These 2 points are near to each other. So what it will do, it will try to associate with this particular point and create one single cluster over here in this particular place. So it will try to create a cluster. So it will say that, okay, fine. So this is the centroid, this is the random points. And let's suppose this is the nearest possible point. So I'll try to do some sort of a association with this one. Now, if I'm going to add one data with other data, so can I say, or can I make a statement over here that its centroid point is going to shift? Yes. So its centroid point, right? Centroid is going to physics class with the answer said. So yeah, it's actually a physics, or you can say math, right? So can I say that here, right? So here your point, so your centroid is going to shift from here to here, because now we are trying to calculate a centroid of which one? Centroid of this entire object, right? This entire object. For example, I'll just try to give you a very simple example, which I give almost in every classes, right? So let's suppose this is a remote, right? And maybe I'm like able to balance out this particular remote in this place, right? Just by like placing my finger over here. I think my screen is visible, right? Like basically I'm visible to all of you. Yeah. Now, if I'm going to place some object over here, if I'm going to place over here, so can I say that it will try to shift its centroid, right? And maybe I'll have to keep a centroid somewhere over here, right? I'll have to shift my centroid if I'm going to place an object on this particular place, because center of mass is going to shift, right? So whenever there is an object, and if you will keep on adding something on that particular object, so for sure center of mass is going to shift, its center of gravity is going to shift, right? And just because of that, so its centroid will keep on shifting. This is a like a nuksan ho gaya, nahi kuch nahi hua. It was just a keyword. So here, right? So here, what we are trying to do is, so there was an object, right? This was an object. We have added a new object, which was nothing but our data points. So its centroid will shift from here to here, right? Now, from this centroid, so maybe this is the nearest object. This is the nearest object. So what it will do? So now it will try to bring all of these three objects all together. Then again, centroid will shift and centroid will come somewhere over here. Then again, you are going to add another object. So centroid will shift. So centroid will keep on shifting. So centroid will keep on shifting from one place to another place, one by one, one by one, one by one. So previously my centroid was here, then it has shifted somewhere over here. Then if I'll, so when I was adding this one, when I've added this one, then when I was adding this another object, so again its centroid will shift over here. Then I'll try to add another object and again its centroid will keep on shifting over here. And same thing we are going to do for point number 2, right? So point number 2 in parallel, right? So this is the centroid in a very first place, and once I'll try to associate this object, so my centroid will be available over here. Then again, if I'll try to add this object, so my centroid will be shifted somewhere over here. Then again, I will try to add this object, my centroid will be shifted somewhere over here. So I will just keep on shifting this centroid. It simply means that we are, and every time we are trying to calculate a distance from a centroid, right? So if I keep on doing this process, right? So can I say that there will be a situation I'm going to encounter, right, where all of this data set will be a part of one group, right? And all of this data set will be a part of this group, and centroid will be somewhere over here. If I'll just keep on calculating a minimum distance from a centroid to a next data set, and then if I'll keep on adding it, can I say that? Right? Yes. So what we are trying to do, so we have started with the random points because I don't know, right? I don't even know that what is my starting point. I don't know which data set I'm supposed to select, right, to create this kind of groups. So what I will do is, so I will just try to take 2 random points because value of my k is equal to 2, and then I will just keep on shifting, or I will just try to keep on creating a cluster one by one, one by one, one by one. Let's suppose if I'm going to take value of k is equals to 3, right? So value of k is equal to 3. So in that case, what will happen? 3 random points it will try to create, right? 3 random points it is going to create, and then this will keep on doing an association. This will keep on doing association. This will keep on doing association one by one, one by one. So it will keep on taking all of this data set in its group, right? It will just keep on taking all of this data set in a group. And then finally, you will be able to find out only 3 groups over here because k is equal to 3. So number of groups we have already decided, right? K is equal to 3. So 3 or k always decides that how many number of groups we are going to create. But we have not even decided that how we are choosing this value of k. Okay. So here, right? So here it will keep on creating all of this like groups. It will try to create each and every time, right? So this time it will end up creating 3 groups. Last time we were trying to create 2 groups, or by default, when we have a data set, when we are not trying to apply any algorithm, there will be only one group of the data, right? All the data set will be a part of one single groups. So again, k is equal to 4, k is equal to 5. So that many number of the groups it will keep on creating. Now, let's suppose this is what happens at the time of training. So when I'm going to define a value of k is equal to 3 or value of k is equal to 2 or whatever it is, right? So it will just try to create a group. That's it. Nothing else it is going to do at all. So let's suppose I have created 2 groups, right? Now there is a next data set which is going to come. So this is the new data set. Now this is a cluster 1. Let's suppose I have created, and this is a cluster 2 which I have created out of this particular approach by shifting my centroid again and again and again. So now let's suppose there is a next new data set I have received, just like a salesman problem, right? So like a salesman has received a new lot of shoes, and he is supposed to decide that, okay, fine. So where I'm going to keep that particular shoes. So what salesman will do? So salesman will go and check that, okay, fine. So new lot of shoes is similar to which groups or similar to which section in my shopping mall. And then it will try to keep that particular shoe over there, right? So say, let's suppose I have a new data. Let's suppose D1. This is the new data point that I have, and I have a problem that, okay, so whether this data set I should keep in a C1 or maybe into a C2. So what it will do over there? So it will again try to check, okay, fine. So this is a cluster. This is a cluster. Now from which cluster centroid it is having a lesser distances. So if it will try to calculate distance between this and this, or this and this. So whichever is going to give a lesser distances, it will try to place itself in that particular group. So it will try to say that, okay, fine. So I belongs from a group C1 or cluster C1 or a cluster C2. And this is how, this is something called as prediction in case of a clustering. So if we are able to find out that this new data set belongs to which group, that is something called as a prediction. And that is something that we are supposed to achieve over here. That is something that we are trying to achieve based on this one. So is this idea clear to everyone? Idea of centroid and how we are trying to move a centroid one by one to form a big groups over here, right? Okay, so the main part over here is how to find out the value of K. We have taken value of K randomly. That's completely fine. 2, 3, 1, 5, 10, whatever it is, right? But how, right? What value of K I'm supposed to select? That's a major problem. People are going to ask you a question based on that how we decide a value of a K at any point of a time. So how random point selected? Random points, it's a random point itself, right? So random points means it will just generate K is equal to 2 if you have given. So it will just try to generate 2 random points in that number of the coordinates. So let's suppose I have 2 columns, so I can represent it in 2 coordinates. So if I have 3 columns, in that case, I need a point which can represent a 3D coordinates. If I have a 4x values, in that case, I need a random point with 4D coordinates. So this is how it is going to select. Okay. Now here, Pranjali is saying that by calculating a mean of the data set. No, that is something which happens in K-mean plus plus. As of now, I'm talking about K-mean. I'm talking about a Bayes algorithm. Then I'll be talking about a K-mean plus plus. And then I'll talk about this problem of like selecting a random points. I'll try to highlight. So just wait for that point. Okay. Now here, so grouping will end when cluster overlaps. Is it? No, grouping will end when all the data points will be a part of either this or that. Simple. Then only it is going to end up grouping, right? So here, right? So here, let's try to understand that how we are going to select a value of a K, right? Because that is like a something that we are supposed to like a calculate, or that is something like that we are supposed to find out, because unless and until we are not able to find out that in how many groups we are going to divide a data set, it's of no use, right? I will not be able to build a model. Okay. So here, right? So here there is something called as concept of inertia, right? A concept of inertia. So it's not the same inertia that we have we know, right, from our physics classes since a childhood. So here it's like a little bit different. So we'll try to understand what is the meaning of inertia over here and how we are trying to calculate a value of K mean. But before that, let's try to take this assumption. So how we are trying to do it. So let's suppose I have a data points. So I have a multiple data points over here. Okay. So I have a multiple data points in this particular place. Now, so how many maximum number of clusters that I will be able to create, or maximum number of groups I will be able to create? So can I say that I will be able to create a maximum number of groups is equal to the number of data set, means maybe n, right? Let's suppose I have total n number of data set. So how many number of groups I will be able to create? Max to max n, where individual data set will behave as a cluster. This is what we can do at any point of a time. So maybe length of the data set, simple, right? Number of rows. So that means number of the clusters I will be able to create. Okay, fine. Now, so here, right? So if I'll ask you to do a very small and a very simple calculation in this particular place, and there is something called as WCSS. It's called as within cluster summation of square, right? So what is this meaning of within cluster summation of square? Just try to understand this part, right? Within cluster summation of square, right? Now, what is our meaning of it? So what is our meaning of this within cluster, right? Summation of a square. So meaning of this within cluster summation of a square is nothing but if like we will keep on dividing, or if we will keep on creating a n number of clusters, then what will be a distance of a data points to its centroid and a summation of it. Again, it looks like a little bit confusing terms. So let's try to simplify this entire term, and let's try to understand in a very, very simple way that how we are going to calculate a summation of a square, or like a within cluster summation of a square, how we are going to create, or how it is going to help us out, right? How it is going to help us out to perform or to find out a value of a k over here. So let's suppose I have only one cluster, k is equal to 1, and just give me an answer, right? Let's suppose I have value of k is equal to 1. So can I say that this will be the cluster? Okay, agree everyone? Okay, fine. Now, can I say that centroid will be somewhere over here? Agree again, right? Okay, fine. So I have k is equal to 1. K is equal to 1 means one single cluster. Inside that, all the data sets are available. Centroid will be somewhere over here, hypothetically. Okay. Now, if I'll ask you, just do one thing. Calculate distance between these, this, means calculate a distance of this centroid, right, with all the data points, right? Calculate a distance between centroid, between all the data points. Fine. So what kind of a distances I'm talking about? I'm talking about a Euclidean distances, and I believe we all are aware about Euclidean distances for 2D, 3D, ND, 10, ND, or maybe a 10D kind of a coordinates, right? So can we say that centroid is a mean of the data set approximately? Okay. So here, so can I say that distance between this data points and this centroid, so distance between this data points and this centroid is nothing but just Euclidean distances. So maybe if I have a coordinate x1 and x2, so maybe x1 minus x1 dash plus x2 minus x2 dash, right? So this is going to give me a Euclidean distances. Under root of this one is going to give me a distance between these things. So I'll try to calculate this distance. I'll try to calculate this distance, this distance, this distance, this distance, this distance, right? So within cluster, right? Within a cluster, we are trying to calculate what? Summation of square. We are trying to calculate. So within a cluster, we are trying to calculate this one. We are trying to calculate this entire things, or we are trying to calculate our distance between data points and a centroid at any point of a time. You can say that we are trying to calculate just a distances in between two things, I would say, right? Okay. Or maybe x1 minus x2 square, simple. So we can try to calculate a distance. Summation of a square. Summation of a square means in that case, root won't be here. So just this part will be available. So we can try to calculate it. Now, so if I'll ask you, just do a summation of it, right? Just do a summation of this entire thing. So can I say that if this is a centroid, and let me take only these many number of points, right? This is a centroid. This is one of my cluster. This is point number 1. This is point number 2. This is point number 3. This is point number 4. This is point number 5. And this is a centroid, right? So if I'll ask you to calculate this entire distances, so what you will do? So maybe entire summation of a square is nothing but SS. So SS is nothing but, so like C1 minus P1 square. So I'm just doing a representation over here, right? Rest of the calculation based on the coordinates, I think we all can do, right? So just a representation. Then C1 minus P2 square, C1 minus P3 square plus C1 minus P4 square plus C1 minus P5 square, right? Yeah. So I think this is something that I will be able to get, or I will be able to see, right? Or this is something called as summation of a square over here. So someone is saying that pen is not visible. So shall I increase? Yeah. So yeah, everything we are trying to calculate from where? So everything we are trying to calculate from a centroid itself. So centroid and P1, centroid and P2, centroid and P3, P4, and a P5, and so on. So this is how I will be able to get a summation, right, within a cluster. Now let's suppose I have a multiple clusters. Let's suppose I have a 2-3 clusters. So for all these 2-3 clusters, whatever we will be able to calculate, so that is going to give me a WCSS. That is something that I will be able to find out in terms of a WCSS. So find if k is equal to 1. So this is going to be, for this particular data set, this is going to be a within cluster summation of a square. Now I'll try to extend it, right? And let's suppose if I'm going to create maybe 2 cluster this time. So this time value of k is equal to 2. So for sure for this cluster, this will be the point, and for this cluster, maybe this can be a centroid point, right? So this distances, this. So we have cluster number 1, we have cluster number 2, right? So for both of this cluster, we will try to calculate a distance of this one and of this one, and then we will try to sum up the distances. So let me give you a points over here. So P1, P2, P3, P4, and this is C1. Then this is P5, this is P6, this is P7, and this is C2, right? So what will be a summation of a square for cluster number 1? So summation of a square for cluster number 1 is going to be C1 minus P1 square, C1 minus P2 square, C1 minus P3 square, C1 minus P4 square. And what will be the summation of a square for cluster number 2? So summation of a square for cluster number 2 is going to be C2 minus P5 square, C2 minus P6 square, C3 minus P7 square. Agree everyone? This is something that we will be able to get. Yes. Okay. So fine. This is something that we all will be able to get. Now, what is the total summation? What is the total summation of this one? So can I say that total summation is nothing but SS1 plus SS2? So total WCSS is going to be this one and this one. Summation of a square for cluster number 1, summation of a square for cluster number 2, right? Sum it up, and then this is something that you will be able to get, or you will be able to see. So in general, WCSS formula is represented in this way: a double summation of maybe a C1 minus point P1 of a square. So why double summation? So one summation for the individual clusters and one summation for the cluster in itself. So this is something that we used to write as a WCSS in general. So within a cluster, summation of a square, and this is called as inertia. So where we are going to use WCSS, how it is going to help me out in terms of a WCSS. So again, just try to answer this question to me, right? A very simple question. So let's suppose, right? So we have k is equal to 2, right? Then if I'm going to take k is equal to 3, then if I'm going to take k is equal to 4, then if I have k is equal to n. So in case of k is equal to n, right? In case of k is equal to n, what will be a WCSS? What will be a WCSS in case of k is equal to n, right? So can I say that in case of Just a minute, guys. Okay. So in case of k is equal to n, right? So when we have, let's suppose like these many number of the points, right? So can I say that each and every point, so in case of a k is equal to n, so each and every point will behave as a cluster. So what will be the centroid? Centroid will be a point itself, right? The point itself. So now what will be the SS or summation of a square? Can I say it is going to be 0, right? Can I say it is going to be 0? So in case of k is equal to n, WCSS, right, is going to be a 0 at any point of a time. So when we had only one cluster, right, when we had only one cluster, so can I say that in that case, distance will be maximum? Yes, a distance will be maximum from a data point to a centroid. So summation of distances will be maximum in that case when we have k is equal to 1. So can I say that theoretically distance will decrease as compared to the k is equal to 1 when k is equal to 2? So can I say again it will decrease? A WCSS or inertia is going to decrease. So WCSS is nothing but it's called as inertia, right? So again, someone has told me that someone has asked them a question that like what is inertia? So inertia is nothing but WCSS over here. So can I say that inertia will decrease or WCSS is going to decrease when k is equal to 5, 6 and then n? So inertia will tends to 0 over here or WCSS will tends to 0 over here, right? This is something which is going to happen. So what we try to do is, so we try to create a graph called as elbow graph, or we try to do a plot called as elbow plot. Now, why we do this kind of a plot and what is the meaning of it? What is the outcome that I will be able to get? So there is something called as elbow method or elbow plot that we try to do, where on this x-axis, we try to keep a value of k. And on y-axis, we try to keep a WCSS, or you can say we try to keep inertia. So let's suppose it is going to start from here 1, then 2, because minimum number of cluster is equal to 1. At any point of a time, cluster number can't be 0 if you have a data set. So 1, 2, 3, 4, 5, 6, 7, 8. So let's suppose k means number of cluster is equal to 1, right? Number of cluster is equal to 1. So can I say that I will be having a maximum distances or maximum WCSS, whatever it may be? Agree everyone? Yes. So can I say that when k is equal to 1, so at that point of a time, I will be having a maximum WCSS. When k is equal to 2, so I will be having a little bit lesser. When k is equal to 3, I will be having a little bit lesser. When k is equal to 4, I will be having a little bit lesser. When k is equal to 5, I will be having a little bit lesser. Then 6, lesser, and then it will tends to 0. Can I say that WCSS will keep on decreasing, right? Once your k will keep on increasing. Agree everyone? Are you able to understand this point? Right? Okay. So here what we do is we try to do a elbow plot. So once I will be able to find out a WCSS for k is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's suppose till 20 value of k. So we will try to find out a WCSS. right? And then we will try to plot this particular graph. We will try to plot this particular graph over here. And through this graph, we will try to observe that where we are able to get this graph as a dispersing graph, means after that there is no major changes which is going to happen, right? So where is the dispersion point? Anyone? So where is the dispersion point that I will be able to get? So can I say that dispersion point will be somewhere over here, closer to 5, right? 5 or 6 in between, or maybe closer to 4 to 5, right? So this is a point. So if you will try to intersect this graph, so here this axis or this x-axis, which is representing a number of cluster, is going to give you a value of k. So before training our algorithm, a final algorithm, what we try to do is, so we try to calculate a WCSS, right, for each and every value of k. We try to plot it with the help of what? With the help of ELBO method, because it's just a very simple plot, right? K is equal to 1, what is the WCSS value? K is equal to 2, what is the WCSS value, right? And then you can do a line plot, right? Then you can do a line plot, a very simple one. You can just connect all the dots. So here the dispersion point, after which you will not be able to see a multiple changes, a steep curve, right, that it is going to give you. So that point on this x-axis is going to represent a value of a k. So you can say that okay, find my value of k is equal to 5. So how many groups I will try to form? How many groups are possible inside my data set? So 5 groups are possible. This is how we get to know about the value of k. And this is something called as WCSS within a cluster, summation of a square. So WCSS is nothing but double summation of cluster minus point of a square, right? And based out of that, so we try to plot ELBO graph, ELBO method, and then we try to find out the value of k. Once value of k is ready, then what I will do? So let's suppose if I'm able to find out value of k is equal to 5, then what I will do? What is the next step? So can I say that if this is a data points which is like given to me, right, and value of k is equal to 5, I'm able to get, if value of k is equal to 5, if I'm able to get, so a very first thing which I will try to do is I will try to create 5 random centroids. Yes, so I'll try to create a 5 random centroids, and after that I think we know the game, right? What it will do? So it will just keep on like taking a data set, keep on shifting the centroids one by one. So it will just keep on like taking this data set, right, one by one. So it will again take this data set one by one, right? It will keep on creating a clusters one by one, unless and until all the data set will not be a part of some of the groups or any of the groups, right? So it will just keep on doing this kind of a repetitive things again and again and again. Simple. And then it will try to form a final cluster over here. So this is something happens in case of a k-mean clustering algorithm. So in case of a k-mean clustering algorithm, we try to find out a value of k with the help of ELBO method or a WCSS method, and at the same point of a time, right? And at the same point of a time, so we try to like once we'll be able to find out the value of k, we do the same thing, right? Now, if let's suppose if it is able to create a 5 clusters, if it is able to create it, it's simple. If there is a new data set, fine, just try to give this data set or try to check that this data set centroid is near to which centroid of which particular cluster. How k is equal to 5? I think this is what I was trying to explain, right? K is equal to 5. Please show geometric intuition as well. I think this is what I was trying to showcase, right? A geometric intuition. So is there any other intuition that you're looking for? Because I believe this is geometrical plus a mathematical intuition which exists with respect to k-mean. Yeah. Will there be always one ELBO? Yes. There will be only one ELBO. You will be able to find a very good. Thank you. Thanks, Leon. Maybe explain after selecting a random points once again. Okay, so see, the simple thing is, once I will be able to select this random points, right? Means I will not select random, means just a random point generations it will try to do. So once it will be able to generate a random points, what it will do? It will simply like try to check, okay, fine. So what is the nearest one? It will keep on accommodating that particular instances into a points and will keep on shifting the centroids one by one, one by one, one by one. It will just keep on shifting this centroid. Means we are only trying to learn a value of k. We are not even trying to learn a value of k, right? We are just like a shifting a centroid, and by shifting a centroid, so we are just like, because k is random over here, right? K is random in this particular place, so we are not like doing that. Means we are only trying to, okay, I think I have answered. Will cluster overlap sometimes? No, not at all, because see how cluster is going to overlap any times, right? That there is no possibility, because it will always try to take only those data set which is available. So let's suppose if some other cluster has taken the data set, it will not try to consider, or it will not try to check our distances, or it will not try to shift our centroid according to that one. Okay, now, so this was the, in case we have 100 columns, doesn't matter, 100 columns means 100 dimensional data set we are talking about. This is the meaning of 100 columns. So your even centroid point that you will create, it will be having a 100 dimension. So hope you are able to analyze this things, right? So let's suppose if I have, okay, so if someone is saying that, let's suppose I have a 3D data, right? X1, X2, X3. Can I say that this is the 3D data? This is a 3D data set that we have, let's suppose. Fine. So 1 to 1 is a 1 to 1 is a data set. Then 1 to 2, 1 to 3, 3, 4, 6, 7, 8, 10. This is the data set which is given to me. So how many points I will be able to form? 1, 2, 3, 4, 5. In total, 5 points I will be able to form. Where? In 3D coordinates, right? In 3D coordinates. So whatever centroid I'm going to generate, that is nothing but it's representing a coordinates, right? So it will be having again a 3 axis at any point of a time. So likewise, if we have 100 number of data sets, so for sure there will be 100, the centroid which will be calculated. So it will be having 100 dimension. Again, so I think we all know, if we have to find out a distance between this and this, are we able to find out distance between this and this? Yes, right? So 1 minus 1 is square, 2 minus 2 is square, plus 1 minus 2 is square. Now what are the distances? This will be equal to 0, this will be equal to 0, 1 minus 2 is equal to 1 square is equal to 1. Okay, so this is the distances which I will be able to find out at any point of a time between these two. So let's suppose if I have 100 dimension, if I have 1000 dimension, doesn't matter at all. It's the same calculation that we are trying to do. Yeah. So if my whole data set is numeric, then we should use a k-mean. Yes, indeed, because it trying to calculate the equidistant distances, and based on that, it is trying to create a clusters, right? Okay. Now here, right? Let's try to understand this part, right? So in interview, people will ask you one simple question: that what is a drawback with a k-mean clustering algorithm? What is the major drawback with k-mean clustering algorithm? So a major drawback with respect to k-mean clustering algorithm was this one. Let's try to, this is very important actually. So a major drawback which was there with k-mean algorithm is allocation of a centroid. Let's suppose I have these data points, right? I have this data points with me. All of these points are there with me. Fine. Now, k is equal to 5. So with the help of this elbow method, right? So we are able to find out value of k is equal to 5, let's suppose. So here it is trying to converge, or here it is trying to disperse. Here, so k is equal to 5. What if I will end up allocating all of this 5 centroid, or maybe 4 over here all together? What will happen in this case? Is it going to work as expected? Because this centroid points, let's suppose k is equal to 5 is a number which I am able to get. So k is equal to 5 simply means that randomly I'm trying to generate 5 points. This is the only meaning, right? Fine. I have generated randomly 5 points. So I have 5 points over here. I have points over here. I have points over here. I have points over here, I have points over here, and I have a points over here. That's completely fine. We are able to generate 5 points in this particular place, right? But is it going to work? I don't think so, right? So it is not going to work. The reason behind this one is that it will always try to take a nearest possible data set, let's suppose, right? It will shift center. So let's suppose if one centroid has participated and it has already taken a nearest one, right? Will other centroid, or will other this like a centroid that I have allocated will be able to find out a nearest point ever? No, right? It will never be able to find out any nearest point. So will this points will be able to create its own cluster? Although I have initialized k is equal to 5, it simply means that there is a possibility that there may be a 5 clusters, 5 groups in which I may divide a data set. But is it going to work? If I'm going to take my centroid, all centroid maybe nearby, right? So other centroid will not be able to take that one. And this is basically a drawback of our base, or maybe a naive, or maybe a initial k-mean algorithm. Then in a later stage, people have proposed a solution. Researcher has proposed a solution. David Arthur, Sergey, right? Charles Elenk. So these people have proposed a different like a solution to overcome this particular problems. And now this algorithm named as k mean plus plus. It's nothing but just to overcome the previous problem. They have introduced suggestions, and they have introduced a solution, and they have just renamed this algorithm as k mean plus plus. So people even ask a question in this way, that what is the difference between k mean and k mean plus plus? Why k mean comes into a picture? So I think at least we have an answer now, that there is an issue with a centroid allocation with respect to a k-mean, because randomly we were trying to choose a centroid in k-mean plus plus. So we are trying to handle these things by proposing some sort of a solution by which this kind of a concern or this kind of a conflict will never arise, right? So here, what David Arthur or Sergey has introduced in 2006, right, with respect to this k-mean plus plus algorithm, they suggested that, okay, you are trying to generate random points, a random like a centroid, right? But as we all know, there is a chance that those random points, those random centroids will come together. So let's do one thing. So let's try to place a centroid, but at certain distances. So just try to place one very simple rule. It's not again like a very major improvement you will be able to find it. It's a minor improvement. They have suggested that, okay, you are trying to create a centroid, but never take a points where distance between these two centroid initial centroids are very close. Always try to take a points with certain distances, and that as a hyperparameter, so you can try to control, so that you will be able to build a best possible cluster, and there won't be any kind of a conflict. And in this way, you will be able to remove a drawback of k-mean algorithm. Is it fine to all of you? What is the difference between k-mean and k-mean plus plus? Yes. And what is the solution which was proposed by Sergey and David Arthur and Sergey, right? So what was the solution which was proposed? This was not the only solution which was proposed. There is a multiple version of solution that you will be able to find out over a Wikipedia, or even in their research paper, right? It's widely available, so you can go and you can download it. So what kind of exact solution that they have proposed, right? So in again 2003, before Sergey and Arthur and Sergey, because they have proposed the solution in 2006, before Arthur and Sergey, so Charles Elenk has proposed again one solution. Before them in 2003, they have proposed a solution, and they said that maybe, right? So there is a problem with respect again to handle or to tackle the same problem. There was no other problem to handle same problem. They have said that okay, so maybe like unnecessary distance calculations we are like trying to do, and yes, so again and again we are trying to calculate our distances. So they said that okay, fine, so just do one thing. So maybe if you can draw a triangle, right? And we all know that if there is a triangle and if A and B and C, so A plus B, right, will always be greater than C. So maybe based on this rule, so you can avoid calculating our distances, and based on this rule, so you can just try to like accommodate all the data set immediately into a single cluster. So once it will fall under this one. So this is again another solution, so which we have proposed. There was another improvement you will be able to find out by David Schooley in 2010. So they said that okay, so what we can do is, so maybe instead of providing all the data set at a time, right? So instead of providing all the data set at a time, so let's do one thing. Provide a data set into a small batches. So just break down all the data set into a small batches, and then try to provide these data sets at the time of building those clusters, right? Don't provide all the data set, don't showcase all the data set, just keep on providing a small data set, right? And that is something called as mini batch k-mean. So there are a multiple version of k-mean you will be able to find out. So there is something called as k-mean, there is something called as k-mean plus plus, and there is something called as mini batch k-mean. So inside this one algorithm itself, so you will be able to find out a multiple variants of this same algorithm. So is this things fine to all of you? Okay, fine. So hopefully we all are able to understand what is k-mean, what is inertia, what is WCSS, what was the like a drawback of original k-mean algorithm, what is k-mean plus plus algorithm, what is a mini batch k-mean algorithm, right? So these things I believe we all are able to understand. Plus we all are able to understand what is the meaning of unsupervised learning, why it is important. Whenever you are explaining these things to someone, so you can try to use my salesman example, right? That how salesman is going to place this shoes or maybe like clothes in some like stores or maybe in some shopping malls. So this is a similar kind of a things that we are trying to achieve over here at the time of training as well as at the time of testing. So I think this is what we are trying to do. Now let me just like share official library. Yeah. So yes, inertia or WCSS, this is what it means. I think I told you what is the meaning of inertia. So inertia is not a fancy word. So if people are asking you, can you please explain me inertia? So don't get confused. The same thing, WCSS. So explain them with a proper example, right? By drawing all of those pictures. Can you explain selecting a K from the elbow graph one more time? Yes, I will. I don't have any issue in terms of explaining you things. I think mini batch k-mean we are able to understand k-mean plus plus. Right. So I told you David and Sergey, author David and Sergey. So they have proposed this particular paper, and they said that okay. So like maybe you are trying to allocate like a centroid, but there can be a class and there is a possibility that centroid will be very closer to each other. So it's better to keep it at certain distances. So they have done this improvement. In terms of mini batch, so we are not sending all the data set at a time. So we are sending a data set in a chunk, right? So that is something which happens at any point of a time in case of a k-mean algorithm. So this is fine, right? This is what happens. And let me talk about it's a parameter available inside a k-mean. There is a parameter, or else I'll show you in an implementation side itself. So over there, parameter you can find easily. Okay, they have just given a matrices, nothing else. So here for scikit-learn k-mean algorithm, right? So by default, which algorithm it is using? Unupdated one. So when you are going to see an implementation, when you are going to do an implementation, so actually you are not implementing a k-mean. You are actually implementing a k-mean plus plus by default, right? So remember it. Even I have asked this question to many people that okay, so you are saying that you are using k-mean algorithm. Have you ever checked? So I generally ask question in this way that okay, so do you know clustering? People say yes. Okay, which one? So they will first of all say, sometimes they will get confused between k-mean and knn, right? That is obvious for our beginners, right? So don't get confused. I'm just telling you. And then I ask a question that okay, fine. So like you have used k-means. They say yes. So are you sure you have used k-mean? And they just keep on saying yes. So you are actually using k-mean plus plus, right? So k-mean is only limited to a theory. It means practical. It's a k-mean plus plus algorithm that they are using. A problem with the people is they never do shift and tab, and they never check what they are using. They just know how to pass a data set and like get some result. And when it fails, when they are like able to get a very less accuracy, then they say, okay, things are not working, right? But there is a way by which you can try to make things work. Yeah, we never thought about it. That's a problem, right? I keep on telling you, do shift and tab at least. Try to understand all the parameters. Otherwise, what is the meaning of using some libraries? Okay, so fine, no issue. Going forward, I believe you all will do it, right? So there are multiple parameters, k-mean plus plus. So I believe we all understand what is the meaning of k-mean plus plus, introduced by David Arthur, right? So yeah, and n init, right? So number of times k-mean algorithm will run in a different centroid seeds. So if you are going to like if you would like to test this centroid things, so 10 times means 10 times it will try to generate a 10 different centroids, then it will try to build it, and then it will try to check. So again, you can try to initialize it with init. Maximum number of iteration can be done by a max iter, right? Again, tool is nothing but just a floating point number, so it just like help you out to tune your algorithms in a little bit better way. Verbosity, I think we all know the answer, so it just helps you out to give you an internal outcomes. So you can try to keep verbose is equal to anything except 0, so it will try to give you all the log, right? Again, so there is something called as a copy X. So it's always try to pre-compute our distances between multiple different kind of instances, and then it will try to allocate a data set. So that is something happens with respect to copy X. And yes, so there are something called as algorithms you will be able to find out inside a k-mean. So there is something called as a auto, there is something called as a full, there is something called as a LCAN. So again, these are just a way by which it will be able to create a clusters, or it will try to distribute one data set to a particular centroid. This is something which happens, right? Shift करते हैं, shift and tab बहुत समझने के बाद अब करने का आदत पड़ गया है. That's great. So k-mean is a clustering algorithm. Knn is a classification. Knn can be used for classification as well as for regression, both. Again, this creates a confusion. So when I ask knn, can I use knn for regression? They say no. I have just used like a linear regression for a regression, but no, that is not true, right? Even knn can be used for a regression as well as a classification. So I think we have already studied those things, right, in our previous classes. Okay, fine. Moving ahead. Now there is another algorithm you will be able to find out, and that algorithm is called as hierarchical clustering. So what is the meaning of this hierarchical clustering and how it works? Again, it's a very simple algorithm, let me tell you, right? It's a very simple algorithm. So this is the next algorithm that we are going to study. So this is called as hierarchical clustering, or I can say agglomerative approach. So whenever we try to build a cluster, so we either follow agglomerative approach, or we either follow a divisive approach. So the very first approach is agglomerative. Again, this is just a word. Meaning is very simple. Agglomerative, right? And the second approach is a divisive approach, right? So what is this like? What is the difference between agglomerative and divisive? So divisive is nothing but k-mean that we have discussed. So where we are trying to consider all the points as a part of one single cluster, and then we will keep on dividing all of those data set. We'll keep on accommodating all of those data set into a different clusters. So where we take one big cluster and then we try to break it down into small clusters. So this is what we do in case of a k-mean algorithm, right? So we try to consider that, okay, fine, so all data sets are together, and then as per the centroid, so it will keep on dividing it, it will keep on dispersing it, right? So and again, just try to relate in this way, you will be able to remember for a very long time. And if I'll talk about agglomerative cluster, so what we do is that we always try to start with n number of data points. So let's suppose if I have n data points, so there will be n cluster. So this is the approach that we used to follow. This is the ideology that we used to follow. If there are n number of data points, so there will be a n number of clusters that I will try to create. And then we will keep on creating this n number of the clusters, right? And then we will keep on combining the data points based on certain regulations, based on certain rules, and then I will try to build a groups. So even over here, so in both the cases, we are trying to build a groups itself, right? The final outcome is same, the approach is different, that's it. So here, based out of this divisive approach, so we have discussed k-mean, right? So we have discussed k-mean. So here, based on this approach, we are going to discuss HC clustering or hierarchical clustering approach. So let's try to understand how HC clustering is going to work. Again, it's a basic one. It's not very tough to understand, right? So easily we all can understand even this particular part, HC clustering. It's smaller than this one. So here, the problem with k-mean algorithm is you are supposed to know a value of k beforehand. If you are not having any idea, right, of a k, you will not be able to do anything. Agree, everyone? Yes. So if you don't know about the value of k, you will not be able to draw a centroid, and you will not be able to build a cluster, right? Because number of centroid depends upon a number of value of k, and that we try to find out from a elbow method. Elbow method is using inertia or WCSS versus k. This is the approach, this is the idea that we try to follow in case of k-mean. But let's suppose if I'm talking about hierarchical clustering, right? So in case of hierarchical clustering, this will be different. The approach that we are going to follow is different. So you are not supposed to find out a value of k beforehand, right? And you will be able to build an optimized cluster as well. So this is something called as bottom-up approach, where we have n number of data points. So we will try to consider those n number of data points as an individual clusters, and then based on the similarity, we'll keep on adding it, agglomerative, right? So we'll keep on adding it. So that's called as bottom up, means n number of cluster to n minus n, n minus 1, n minus 2, n minus m number of clusters we are trying to build, right? So here the approach is very simple. So let's suppose I have a data point. So I'll try to consider some of the data points over here. These are the data points, and someone is asking me that, okay, just do one thing, create a groups. So maybe I can try to create a group here, and then I may try to create a group over here. There is a chances, there is a possibility that I may create a group here, and I may try to create a group in this particular places. That's completely fine. But how we are going to, and with respect to k-means, so I think we have an idea, but with respect to hierarchy clustering, so how we are going to create it, how we are going to build this one, let's try to understand. So let's suppose I have a multiple points, right? I have a multiple points over here. I will try to plot all of those points on this axis, right? On this axis. So I'll try to plot all of this point. Just try to focus over here for next 10 minutes. You will be able to understand HC clustering. It's very easy. So let's suppose I have a point P1, I have point P2, I have point P3, I have point P4, I have point P5, I have points P6, I have point P7, I have point P8, P9, P10, P11, P12, P13. The other points I have, right? So no issue. What I will do is, so maybe I will just arrange theoretically, right? Theoretically, this is something which I'm going to do. So maybe I can try to keep my point P1, I can try to keep my point P2, I can try to keep my point P3, and then P4, P5, P6, P7, P8, P9, and so on, right? You missed one point in first cluster. Yeah, that's fine. So forget about it. I'm just trying to give you a theoretical explanation, right? So fine, these are the points that I have and so on. And someone is telling me that build a cluster, right? So how I'm going to build a cluster? Let's try to understand. So we have a point P1, P2, we have point P2, P3, we have point P4, P5, and so on. These are the points which is given to me. Now, if you are going to ask me to build a cluster over here, so fine, I will try to build a cluster. There is no issue, but this time, so I'll try to treat all of these points as an individual cluster. So as of now, I have like a 13 point. So I have 13 number of cluster. This is what I will consider. So in total, I have 13 number of a cluster over here, starting from P1 till P13, let's suppose. Fine. So I have 13 number of cluster. Now what I will do over here. So I'll try to check, maybe based on the distances or maybe based on some other similarity. So I'll just try to check that, okay, so which point is closer to a point P1? So which point is closer to a point P1? So let's suppose here is a point P1, which is available in this 2D axis, right? So I'll try to calculate P1 to P2, P1 to P3, P1 to P4. So which one is the nearest one, right? So let's suppose P2 and P1 is a nearest one. So what I will do is, so I will try to create one vertical line in this way. And I will try to combine these two cluster or these 2 points. This vertical line that I'm trying to draw over here. So this vertical line is representing a Euclidean distances. Again, vertical line, right? Not this horizontal. A vertical line is representing a Euclidean distances or whatever measurement that you have taken to like compare these 2 points, right? So let's suppose as of now I'm considering Euclidean distances. There are again multiple different kind of linkages which is possible. So I'll be talking about a linkage over here, right? And meaning of a linkages in case of a ST clustering. But over here, right, this vertical line is actually representing a Euclidean distances or distances between P1 and a P2 points. Very simple, right? Okay, so P1 and P2. So I had 2 points, P1 and P2. Now they are a part of one cluster. Fine, they are the part of one cluster. Similarly, I'll try to check like what is the distance between P3 and P4. So if P3 and P4 is the nearest one, I'll try to combine. P4, P5, there is a possibility that P7 and P9 are the nearest one. Possibility, right? So I will try to combine two, this kind of things. I'll just keep on combining these two, right? Maybe P8 will try to combine or associate with something else. So it will do that. Then what I will do, so again, maybe I can try to create another kind of a linkages. So I'll try to like create this center point right, which is nothing but a centroid. So which is representing, let's suppose, a centroid over here. So what I can do is, so let's suppose if this is representing a centroid, right? So again, I will try to calculate a distance between this centroid and this centroid is minimum, or this one is minimum, or this one is minimum, right? So let's suppose a distance between this one and this one is minimum. Again, this vertical line is representing a distance between these two centroid, right? These two centroid over here. Then let's suppose distance between this one and centroid, which will come now over here, is minimum, right? Then maybe like a distance between this and this centroid, because all of them are sold out, right? So all of them are sold out. So here distance between, okay, so it's a yellow, right? It's not visible. Maybe I can try to use this. Okay. So distance between this and this is minimum, right? So I'm just trying to like follow a bottom up approach. So first of all, I have taken number of cluster is equal to number of points. Then I'm just trying to attach these points all together, one by one, one by one, one by one, right? And we are trying to combine these things. Yes, we are trying to, we'll just keep on like a bringing up together. We will keep on doing these things unless and until we will not be able to add. We will not be able to add each and every point which is available, or we will not be able to attach each and every point which is available, or we will not be able to touch each and every point which is available inside our data set, right? Then you may ask a question, then how you're doing a clustering? You're just trying to add the points and trying to build a pyramid over here, right? So what will be our number of a cluster? What will be our who and what data set belongs to which cluster? How it will be decided? So this is an approach that system uses to follow, and this approach is called as dendrogram approach. In K-mean, it was an elbow method to find out the value of K. Here, it's a dendrogram method, right? This is called as, this approach is called as, the graph which I'm trying to draw over here is called as dendrogram graph, D-E-N-D-O-G-R-A-M. Dendrogram, right? So this is a dendrogram that we try to draw. Then we try to check which vertical distance is more, right? So which one is more? This one, this one, this one, this one, this one, or this one? Which one is more? Yes, which one is more? So can I say that this white one is more, right? This white one is more. So from a mean point, right? So let's suppose this is a white graph, that white line that we have. This is like a one of the biggest one, right? So from the mean of this one, we will try to draw a horizontal line. So this horizontal line is intersecting at how many points? Can I say at 2 points it is intersecting, right? So ideally it is going to create two cluster. Now, what kind of a cluster? Which data set will belong to cluster number 1 and which data set will belong to cluster number 2? And why we have taken this biggest line, biggest vertical line? So can I say that we have an answer why we have taken the biggest vertical line? Because this biggest vertical line is representing actual distances between a data point or between a clusters or between a centroid over here, right? This is what our biggest line, this is the meaning of this vertical line at any point of a time, right? It representing a distance between these two. This line is representing nothing but distance between this and this one, right? So this is something which happens. So here two cluster is possible from this one. So can I say that this, all this data points P1, P2, P3, P4, P5, P6 is a part of this cluster, and this will be a part of this cluster? We are trying to do the same thing. We are just trying to like find out that, okay, which point will go to which one. That's it. Here, only thing is approach is different. We are trying to use a dendrogram approach, and based on that, so we are trying to separate a data set. Yeah. So is this things fine to all of you? And this is called as hierarchical clustering by using a dendrogram approach, or you can say it's called as agglomerative clustering approach. So agglomerative is nothing but bottoms up approach we are trying to use over here. So we are starting ahead with the n number of clusters, and then we will keep on adding up points. What is a dendrogram, sir? This structure is dendrogram, this hierarchy that I've created, right. Will the pair be unique? Yes, yeah, for sure. In that case, pair will be unique. Why we selected the white one? Because the vertical distances is more over here, right? So that is the reason. So we have selected the white one. Horizontal line means, so let's suppose horizontal line is intersecting at two places. It simply means that it is creating two clusters. This is one, this is the another one. If we are intersecting from here, then how many clusters? Can I say 1, 2, 3? Yes. Is it visible clearly? Yeah. So it simply means that we can try to we can make horizontal line at a point. See, it's not like we can create a horizontal line over here. So I have clearly given you instruction that at the mean of it, right, you are supposed to create a horizontal line. It's not like you will create a horizontal line over here. Then you will say, then if you are creating a horizontal line over here, in that case, what will happen? So can I say that if I'm creating a horizontal line over here, so in that case, number of clusters is equal to number of data points? Yes, we don't do that. It's a mean. Okay, fine. So I believe this HC clustering is clear to all of us, right? So this is one of the approach where we are not defining the value of K, right? Or any such kind of a things. We are just trying to draw it, right? Now here, why we are using the longest vertical line? Because when you will say that you are able to separate a data set more clearly, when distance between two groups will be completely different. If distance between two groups are close to each other, can I say that you are not creating a separations, right? The graph is what versus what? The graph is point versus nothing. Point versus the graph that we are. So this graph which I have drawn over here is actually showing you the internal mechanism of creating these two clusters. So how internally this cluster will be created. System never draws this kind of a things automatically. System is actually just trying to calculate this distance. So that's it. So just to show you the internal mechanism of it. So it's like a graph I have shown you. Yes. So dendrogram approach, by which I'm just trying to explain you that, okay, fine. So internally, this is how this HC clustering algorithm is going to work. Now, moving ahead. So there is another algorithm. So again, HC clustering is completely fine. But let's suppose if I have a different kind of data set. So in that case, or maybe a different shape of the data set. So in that case, my HC clustering is going to fail. So guys, I think we can like take a 10-minute of break, right? It's a 4:48 as of now. So maybe we can take a break till like a 5 p.m. IST for next 11 minutes. And then again, we can start, right? So we are going to start with DBSCAN, density-based spatial clustering of the application with the noise, right? This is one of the most powerful clustering algorithm you will be able to find out. Way more powerful than your k-mean and your hierarchical clustering. So let's take a break, guys, and after that, so we'll try to understand a DBS scan, right? So we have a break till 5. नाम से खतरनाक लग रहा है DBS scan, but it's one of the useful one, a best one. It's fine, guys. Just take a break. Okay, so fine everyone, I think we are back, right? So now let's try to understand what is DBA scan. So it's a very important algorithm as far as clustering is concerned, right? So full form of this DBA scan is nothing but density based spatial clustering of application with noise. So density based spatial clustering of application with noise, right? So here, this is called as DBA scan. So Mom is saying that is it related to a databases? No, it's not related to a databases. Again, it's related to a same problem statement, a grouping problem statement. So let's suppose if I have a new object in my hand, so where I'm supposed to place it, so it's related to that, right? So let's try to understand what is a theory behind this DBA scan and how DBA scan is going to create a groups. In case of HC clustering, hierarchy clustering, so yes, it was trying to create a groups. In case of a K-mean clustering, so yes, it was trying to create a groups. So here, how this is going to create a groups, and here, so you are supposed to remember a certain points. So let me write down those points over here. So here you are supposed to know about epsilon. That is the first point. Then second point is a minimum points. It's the same point, it's the same parameter you will be able to find out even at the time of implementation, right? Core points, there is something called as border points, and there is something called as noise. So these are the things that you are supposed to know when you are trying to understand a density based spatial clustering of application with noises. So this is something that we will try to understand. So let's try to see so how it is going to work and what is the meaning of this different points that we have, right? So epsilon is nothing but it's a distance. It's a relative distance that we use to give. Minimum points is nothing but the minimum number of points which you will be able to accommodate inside a particular cluster to create a particular cluster. As of now, just try to understand in this way. Core point is nothing but which is going to satisfy a minimum point criteria. Border points is nothing but a points which is a part of some cluster, but they are not going to form some of the other clusters. And noises are nothing but a point which is not a part of any of the clusters. So this looks a little bit like a clumsy. This looks like a little bit like a different and difficult. So let's try to clarify all of those points one by one. I'll take some data set over here. So let's suppose I have some data points with me, right? So these are the data points which is available with me, let's suppose, right? And yes, then we'll try to do a comparison as well. So between a DBA scan and between a K-mean clustering algorithm. So these are the points which I have taken. And now I'm asking you to create a cluster or maybe create a grouping of this entire data set, right? So grouping of this entire like data set, if I have asked you, and if I have asked you that, okay, fine. So tell me how many minimum number of clusters that I will be able to create. So yes, we can perform the same operation with the help of K-mean, with the help of HC, and even with the help of DB scan. But there is a differences, and there is some sort of relations or some sort of advantages you will be able to find out if you are using a DB scan, right? So here, what happens is that we try to define two things in a very first place. One is called as EPS, and another one is called as a minimum points. Now, it's the same thing that I have written over here, epsilon and a minimum points, right? So we try to define two things over here, EPS, epsilon, right? And nothing but second thing is minimum number of points. So let's suppose epsilon is equal to 1 I have defined, or maybe 0 0.4, 0 0.5, or something like that I have defined, which is representing a distances. And minimum point is equal to 3 I have defined over here, right? So this is something which I have defined in this particular place. So what this algorithm will try to do automatically over here is that it will start from any of the random points which is a part of my data set. So all of these points, right? All of these points are the part of my data set. So it will try to start from any one random points it will try to start, which is not visited yet, let's suppose, right? So let's suppose I will try to start from this point, or maybe I'll try to start from this particular point, and I will try to create a circle or I will try to create a radius over here. So let's suppose this is a point which I have chosen, right? And then I'm trying to draw a circle from this one, right? I'm trying to draw a circle from this particular point. Now, what is a radius of this circle? So radius of this circle that I'm trying to create is nothing but EPS that we have defined. This is a radius. So EPS is nothing but it represents our distances, and which helps you to create a circle at any point of a time, any point of a time. So this is the point I have taken, and let's suppose this is a radius. So this is nothing but my EPS, right? So let's suppose EPS I have defined is equal to 0 0.4, 0 0.5. So it is going to create a circle. So fine. Once I have created this circle, and once I'm able to like create the circle with the help of this EPS, then I will try to check that, okay, how many points are there inside this circle? So inside this circle, how many points are there? Yes. So here, so can I say that inside this circle, I have total number of data set available is equal to 2, right? So total number of data set is available is equal to 2. This is one of the data set, and this is another data set available to me. Fine. So it's completely fine that this particular point is a kind of a neighboring point for this first point, first reference point, or first random data set that I have chosen, right? Random point that I have chosen. So I'm able to draw a circle. But what is a minimum point that I have defined? So these are the two parameters which I have chosen, right? Which I have opted for. And these are the hyperparameter. So we are supposed to, so when I say hyperparameter, it simply means that value is not defined. You are supposed to find out the best possible one. So total minimum point I have defined over here is equal to 3, right? And a total number of points which comes inside my circle, which I can see over here, is equal to 2. So what happens in that particular situation, and what it will be able to like or whether it is going to form like a cluster, or whether it is not going to form a cluster. So let's try to understand. So can I say that a circle which I have drawn over here, so it is not satisfying a minimum point criteria? A circle which I have drawn based out of the EPS values, right? Which is nothing but representing a radius of the circle, right? So it is not able to contain a minimum points which is equal to 3. So if this is a case, right? If this is a case, in that case, what will happen? So in that case, it will not be able to form a cluster at any point of a time. So this is not eligible. This point is not eligible to form a particular cluster at this point of a time. Fine, no issue. I'll try to do one more thing. I'll try to run one more experiment over here, right? So maybe I can try to choose this point this time. And EPS, right? So let's suppose if I'm trying to draw a circle over here. This time I have drawn this particular circle based on the EPS values, right? Now, how many data points do we have inside this one? So can I say that 1, 2, 3, 4, 5, including that point itself? So in total, I have 5 points, right? So can I say that 5 is greater than 3 or 5 is greater than the minimum points that I'm looking for? Yes. So it is now going to form a cluster, and a point that we have taken, so that will become basically a core point. So this will become C, or this will become a core point over here. It's a very simple thing, right? So this will become a core point because now it is able to form a cluster, right? Then what I will do, so then I will try to take all the points which is a part of this core point, or which is a part of this entire circle, right? So we have this point, we have this point, we have this point, and we have this point. So maybe I can try to start, and then I can start, right, doing a same thing. So based on the EPS, so I will start drawing a circle, let's suppose, right? So how many points we have over here? Yeah, so how many points we have over here? So can I say that only 1 point? So is it going to form another cluster? No, right? It is not going to form another cluster at all. So here, so yes, but this particular point, can I say that it's already a part of some of the core point? So it's already a part of the cluster, but yeah, it is not able to extend this particular point, or it is not able to extend these things to some other circle. So fine, it's a neighboring point of this core point, but still it is not able to accommodate any other points. Then maybe I can try to take this one, and then I can try to draw a circle over here. Fine. So can I say that this point is able to form a cluster, or when it is going to form a cluster when it is going to satisfy a criteria of a minimum point? So minimum point is equal to 3, and yes, it is able to do that. It is able to achieve it. So can I say that this point will become a core point over here? So this will become a core point at this point of a time. Again, we have ended up generating a multiple neighbors point as well. Now let's suppose if I'm talking about this point, so is it going to form some cluster by itself? No, but it's already a part of the core point. Now, is it going to form a cluster? No, but it's already a part of a core point. So these are nothing but it's a neighboring points. But yeah, I'm trying to find out like whether it is going to form some other cluster or not, right? So here it is not able to form any other cluster, right? By using this particular points, only this points is something which is able to form it. Fine, no issue. Now here, right? Here, let's suppose if I'm trying, this is the left out points. We have not considered this particular point so far, so forth. So let's suppose this is the point which I'm trying to consider. So is it a part of any cluster, this point? Is this point a part of any cluster? No. The reason is, so this was not a neighbor points of any core points, right? This point is not a neighbor points of any of the core points that we have taken over here. So if it is not a part of any core points, means it's if it is not a neighbor points, right? And it is not able to form its cluster. So can I say that in this case, it is a noise because it is not able to come inside any of the cluster that we have? Agree, everyone? Yes. Okay, fine. Now I'll try to consider these points. So fine, I'll try to take a EPS and I'll try to draw a circle. Now just tell me one thing. So is this point, right, is this point a part of any core points? No, it's not a part of any core points. Is it able to form any of its own core points? No, it's not able to form any of the core points because minimum points required is equal to 3 to form a cluster, but it is not able to do that. So again, in that case, it will be a noise point, I can say, right? Okay. Now here, so let's suppose if I'm trying to like draw a circle, right? So is it going to be a part of any of the clusters? No, it's not going to be a part of any of the clusters. So again, as of now, this is a left out point. Let's suppose I'm going to consider this point, right? So is this point going to become a core point? Yes, because there are minimum points criteria is equals to 3, which it is able to satisfy, right? So it is able to form a cluster. Now this is the neighboring points, right? So maybe I can try to like draw a circle out of this one. So maybe if it is going to take in this particular point, which is already a part of or if it is going to form a cluster with this criteria, minimum point criteria, then this will become a part of this one. Otherwise, it will not become a part of this one. So as of now, what we have? So as of now, we can say that we have. So as of now, we can say that we have one cluster. We have this one as a cluster, and we have this one as a cluster. So where it is able to be a part of something. Now I can try to keep on checking. So whether this will become a points or not, this is going to accommodate something or not. Then again, we can try to check with this one. So whether it is able to form some clusters or not, or it is going to satisfy this criteria or not. Then I'll try to check with this one, whether it is able to satisfy this one or not. Or I'll try to check with this particular point, whether it is be a part of some clusters or not. So this is not a part of any cluster. 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 This is not any part of cluster. So can I say that all of these points are nothing but it's a noise point, right? And what is the meaning of noise? Meaning of noise is it's an outlier that we have over here. So this DB scan technique is being used to even find out a robust outlier at any point of a time, which is not a part of any clusters that we are able to, or that we are trying to form over here. And now let's try to understand what is the meaning of all of these things. So epsilon, it's nothing but it's representing a distance or a radius. It is trying to represent by which I will be able to form a clusters, right? So this is something that it is representing. Minimum points, so minimum number of points which is required to form a cluster. This is what it is representing. If I'll talk about a core point, a point which is going to satisfy this criteria, where if I'm going to draw a circle, so at minimum that many number of points are supposed to be here inside that one. If I'll talk about a border point, so border point is nothing but a point which is a part of some circle, a point which is a part of some core point, but it is not able to form its own cluster. So that is something called as border point. So this is border point. Again, this is border point. This is border point. This is a border point. This is not a border point. This becomes a core point, right? So border point is nothing but a point which is a part of a core point, but it is not able to extend it by satisfying this criteria that we have written. Minimum border point is equals to 3. So this is something called as density based spatial clustering of application with the noise. So where it will be able to find out even a noise, or it will be able to find out even an outlier, and it will be able to do even a grouping of the data set, or it is able to do a grouping of the data points. Let's take one more example, a neat and clean way, right? So these are the points which I have taken. Let's suppose, I think my screen is visible, right? This blue color is visible to all of you. If not, so I can try to change maybe color of the background. Okay, fine. So these are the points that is given to me. Again, epsilon is equals to EPS is equal to 0.5. Let's suppose I have taken, and minimum points I'm going to take is equals to 4. Let's suppose, right? Okay. So what I will do, so I'll just start like taking, or I'll just start with the random points. Let's suppose I'm going to start with this random point, and then I'm going to draw a circle. So can I say that this will become a core point? Yes or no? No, right? Because to become a core point, so at minimum 4 points are required in one single circle. Okay, so this is cancelled out. We can't consider this point as a core point at all. Maybe I can try to consider this point this time, right? Now, if I'm going to draw a circle, so is it satisfying this minimum point criteria? So can I say that this will become a core point, right? And rest of the points will be, as of now, it's a neighboring points. All these points are nothing but it's a neighboring point. Fine. Now I'll try to draw one circle. It's this one. This point is already a part of this cluster, right? This point is already a part of this cluster. But is it going to extend this extend this cluster? No, because it is not satisfying this criteria. So can I say that this will become what? Border points, right? It is not helping me out to extend the cluster. Now, if I'll talk about this one, can I say that this point will become a border point again? Can I say this point will become what? A border point again? Yes. Okay. Now, maybe I can try to extend this one, right? So it is able to enclose, let's suppose I'm going to keep maybe like a 4 points over here, right? So can I say that now this point will become, this was the neighboring point, but now this point will become a core point? Yes. Yeah. So fine. So not all the circle have the same radius as a yes. Yeah. So radius of all the circles is going to be same, right? But here, as I'm like trying to draw it, so for sure, like I'm trying to create sometimes big circle, sometimes small circle, right? So it's like a very simple. This is data manipulation. So yeah, I'm doing a data manipulation. I'm just trying to add one more point so that this point will become a core point for me. And that's true. Okay. So here, this is like another like a point that I'm able to form. Now, let's suppose if I'm talking about these points. So can this point will become a cluster? No. 4-point criteria is not going to satisfy, right? So no, fine. Now, if I'll talk about any other neighbor points, let's suppose this as a neighbor points, if I'm going to consider. So can I say that this point will become core point? No, because it is not able to enclose 4 points. So fine, just leave this one and leave this one as well. So these are the maximum. Can I say that these are the maximum number of points which we can accommodate for this iteration? This is the maximum number of points which I'm able to ingest inside a single cluster, right? Fine. So this is, let's suppose, cluster number 1 I'm able to form. But we have so many points which is left. We have so many data set which is not a part of any of the clusters. So what I will do with those things, right? Again, I will try to do these things. Randomly, I'll try to select some of the data points. So here, let's suppose this time I'm selecting this data points, right? And can I say that this is forming a cluster? But can I say that this is just separate from this one? These two are not same. This is the second cluster which I'm trying to form, right? Because there was no other extension which I was able to make. So this is the second cluster. So can I say that this is the core point that we have? Okay. Now this is the neighboring points. I'll try to check. So whether this neighboring point is able to fulfill this criteria or not. So it is not able to fulfill. So fine, leave it then. Right? I'll try to check with this one, whether this is able to fulfill this criteria or not. No, it's not able to fulfill, leave it, right? Then I'll try to check with this one. So whether it is able to fulfill this criteria or not, right? So no, this point is already a part of another cluster. No, it is not able to fulfill. There should not be any kind of overlap. So can I say that this is a cluster number 2 that I'm able to form with these points and no other extension I will be able to make? Yes, everyone? Yeah. So now but still I have so many points which is left. So maybe I'll try to start with this one and then I will try to draw this one, right? So can I say that this point, right? So yes, it is, it may become a cluster, right? So fine, it's a separate cluster without any overlap. Now I'll try to consider this neighbor point. So is it going to satisfy like a 4-point criteria? So yes, it is going to satisfy. So fine, I can try to even take this inside and then I can try to consider this as a neighbor points. Again, I'll try to draw a circle. There is no other points which is coming inside this one. Then again, I can try to form this cluster, right? So again, this is not satisfying the same criteria. So it's completely fine. But anyhow, this is a part of your core point. So if it is a part of core points, it's already a part of your cluster. Again, I'll try to draw, no issue. So this I'm not supposed to consider because this will become outlier in that case, right? So again, with respect to this points, are we able to get 4 points over here? No. So fine, not considered. Now, this one, this one, this one, this one, this one, this one, and this one is left. So we have 6 points, which is not a part of any other cluster. Can I say this is C3, cluster number 3? Now, other points are not a part of any of the cluster that we are able to form. So in that case, all of these points will become noise point. Is it fine to all of you? Or you can say it's nothing but it's a outlier. So DBA scan algorithm, as its name suggests, application with a noise. So it will always help you out to even detect a noise or to even detect an outlier out of any of these like a data set that you have given. How we decide a minimum point? Dipendra is asking. So see, I told you very clearly that your EPS and your minimum points are nothing but it's a hyperparameter, right? It's just a hyperparameter. So if something is hyperparameter, no one will be able to tell you that what is a value that I'm supposed to take. You are supposed to hit and trial. You are supposed to do a testing. And then after testing, you will be able to know that, okay, fine. So this is a good cluster or this is a bad cluster, which I'm able to form. So this is the idea behind EPS as well as a minimum points, right? So does minimum points includes a core point? Yes, it does. So including a core point, so it includes a minimum points. Is there any range of the minimum points? No. So if you will keep on increasing, again, there is a drawback over here. If your EPS is very, very high, let's suppose, again, EPS is nothing but a number, like a relative numbers, so that it will be able to draw a circles over here. Now, if your EPS is very, very high, let's suppose I have taken EPS is equal to 10, right? And then if I'm going to start from this particular circle, let's suppose EPS is equal to 10, and then if I'm going to start from this circle, so can I say that I will end up drawing one big circle? Yes. So can I say that this will be a drawback? If my EPS is very, very high, so in that case, I will be having a bigger circle, a very, very big circle. And in that case, what will happen? Your algorithm will fail. So you're not supposed to choose an EPS value, just a random one. So we generally test it. We test it with the different EPS values. We try to draw a cluster. We try to see that, okay, fine. So what is our clusters that we are able to form? And then we finally try to decide it. Now let's suppose on minimum points, right? So if minimum points is very, very high, EPS is, let's suppose, low, and minimum points is very, very high. So can I say that in that case, it will not be able to form even a single cluster, right? Let's suppose if I'm trying to draw this circle, this one, right? And I have given minimum points is equal to 40. Will you be able to find those 40 points in a single circle in this situation? Not at all, right? With this EPS. Yeah. So again, it is going to fail. So whenever we are talking about a hyperparameter, so we are supposed to take, or we are supposed to choose this hyperparameter carefully. And after doing a multiple experiments, no one is going to tell you that what will be a value of your hyperparameter. It is going to change with respect to a data set. If your data set is going to change, for sure, your parameters are going to change. It is not going to be same because variance of your data set is going to change, right? So whenever you are trying to select either it's a EPS or whether it's a minimum points for a DBA scan, make sure that you do a multiple experiments, and then out of those experiments, draw up complete like a DBA scan, which I'm going to do in your like a practical classes and with the multiple experiments. And then you have to select a value of EPS and a value of a minimum points. Do we include in something like a grid search CV? No, it's like a random one. So is there any range for EPS? No, there is no range for EPS. Is there any algo to get this hyperparameter for DBA scan? No, you just do experiments with the for loop and then you will get to know about it. How we distinguish cluster as the points are overlapping. See, points are never going to overlap. First of all, if one point is already a part of some cluster, so that same point can't participate with others. Simple. So there is no overlap, right? David is saying that just now I joined. Is it ML or DL class? Okay, it's a full stack data science class, David. For your information. How to decide initial core points? Is there a DBA scan plus plus? So initial core points can be decided based on the randomness. So like I said, we start from a random points. Very simple, right? Let's suppose I have so many data points. I'll just start from the random one and then I will keep on doing these things. I'm asking, is it a ML algo or DL algo? No, it's a ML algo. Still ML is going on, right? So yeah. So any other question? in interview, they asked to visualize a SVM. I never thought of it. Okay, so yeah, visualization of SVM is easy. So I think we have already discussed about it. And when I have explained these things, so I have taken a data points, and with respect to a data points, I have shown you that this is the hyperplane. These are the margin lines that you are supposed to draw. This will be like a minimum distance in between, and what is the meaning of a support vector. So in this way, you can try to explain and take always x1, x2, and y kind of a data set, right? So with this, you can try to give a references. Fine. So are there any drawbacks? Yes, I already told you drawbacks, right? So drawbacks of this DBA scan is if you are going to take a very high value of a EPS, it will fail. Very low value, again it will fail. Very high value of a minimum point, it will fail, and very low value of a minimum point, again it will fail. So that's the reason. So you have to be very, very careful when you are going to select EPS and a minimum points over here. So that is a drawback that you will be able to find out. So if we keep rerunning, we will have a new core points. No, so you will be having a new core. Yeah, so for sure you will be having a new cluster. So if you are going to change a value of EPS, and if you are going to change a minimum point, so in that case, what you're trying to do? So technically you are trying to reform the entire clusters, right? You're not considering whatever you have done last time. So this is something which happens by default. Okay. Actually saying that I have started Grid Search CV to find the best parameter for HPC. Before this class, till now my system is not able to find out. Okay, so I think you should switch to HPC high computation system. So how to decide with clustering algorithm to use? I'm coming to that point. How to decide which clustering algorithm is to use and when. How this is better than K-mean plus plus. I'll be talking about that as well. Why DBS can be considered as a better than other two algorithm? Just now I'm coming to that point. Yeah. So now I think I should discuss about it, because almost all of you are asking the similar kind of question, that which one is the best one. Okay. So here, what I will do is this picture. Always keep this picture in your mind, right? And now I'm going to explain you that why this picture is very, very important, right? So what happens is, let's suppose if I'm talking about K-mean clustering, I'm talking about HC clustering, which is a part of agglomerative, like bottom-up approach. If I'm talking about a DBA scan, right? These are not the only clustering algorithm which exist. So apart from this, you will be able to find out this as a clustering algorithm, this as a clustering algorithm, this as a clustering algorithm, this as a clustering algorithm. This is again a part of your agglomerative itself. This is again a part. DBA scan, optics, Birch, Gaussian mixture. All of these algorithms are nothing but it's actually a clustering algorithm, right? We have studied DBA scan, right? We have studied K-mean. So here meaning batch K-mean they are representing, right? And we have studied basically this HC clustering. What is also a part of the same one, right? Even mean shift is a part of the same one. So here, just try to remember this picture. So how and when we are supposed to use what kind of a clustering algorithm? Let's try to understand. Okay. So here you will be able to find out that we have a data set given to us with a different shape. Here it's a spherical. Here it's kind of a, you can say, oval, and then here we have some sort of a scatter. Here again we have some sort of a data set. Here again we have some sort of a data set. Here again we have some sort of a data set. This is the different type of the data set which is given to you, just in terms of a graph, right? This is the type of the data set which is given to you. Now just observe over here, just observe, right? We are using K-mean on all of this. We are using affinity propagation on all of this. We are using mean shift on all of this. We are using a spatial on all of this, wide on all of this, agglomerative, all of this, DBA scan, all of this, optics, all of this, Birch, all of this, Gaussian mixture on all of this, right? And this is the result that they are able to get after running this experiment. So here, my data set shape was in this format, right? In this format. So can I say that it is able to separate our data set, and this different color is representing a different clusters? Try to understand in this way, right? So do you think that we are able to create a best cluster over here? We are able to create a best group over here in this case? Someone is saying that please zoom in. I think it's visible, right, to all of you? It's already 100%. Now it's 150% of a stream. Yeah. So can I say that this is a best cluster? Or if I'll ask you, which one is the best cluster? So this one or this one? Which one is the best cluster? Can I say a DBSCAN1 is giving you a better result, right? So with a spherical data set, so the problem with k-mean algorithm is, or maybe HC algorithm or DBSCAN algorithm is, they always works with a different shape of the data. So if shape of the data set is maybe a spherical, so in that case, k-mean algorithm may works well, but there is no assurity, right? K-mean algorithm may works well. Maybe it will try to create a centroid, and based on the centroid, so it will try to split a data set into a different centroid. There is a possibility, right? But here you are able to observe that DBSCAN is performing well. It is able to create group of the data set internally, and for this one, it is able to create another group. Even this one is working well. Agglomerative is nothing but HC clustering, hierarchical clustering that we have discussed, right? So even it is able to separate. Even a spatial clustering is able to separate. But if I'll talk about this, right? This and this one. So can I say that with a spherical data set, it is not working well? Yes. Can I say that? Can I make this statement? Yes. So for this kind of a data set, if you have this nature of the data set, and again, I think we all know how to find out a shape of the data set, right? Everyone? Yes or no? Okay, no answer. It seems from anyone. Okay, no, I don't know. Someone is saying, yeah, we know about it, we can plot it. Fine. So can I say that this is nothing but like a plot of the data set when you have x1 and x2 is given to you? Yeah. What if I'll give you x1, x2, x3, x4, x5 and xn? How you will be able to find out the shape? Kernel trick always try to augment your dimension, so it is going to fail and your answer is incorrect. So can I say, those who have attended my machine learning previous lectures, or maybe if you have gone through your things in a fast track, right? So I used to, and again in your class, I think by next Saturday, I'll discuss this algorithm, dimensionality reduction, right? PCA I'm going to discuss. By next Saturday, I'll discuss about it. So let's suppose if my data set is given in 100 dimension, it is not possible to find out a shape or even to visualize those data set if I have like 100 dimensions in a data set, right? It's not possible. Max to max, you will be able to plot 3D, not beyond that one. So max to max, you will be able to visualize a shape of what? 3D data set. 2D, 3D is fine. But beyond 3D, you will not be able to visualize it, right? But yes, there is a way, because shape is nothing but it just represents a nature, right? So even if I have 100 number of columns, for sure I can't see 100 dimensional data set. What I can do is, so I can try to convert this 100 dimension into 3 dimension, and that is something called as dimensionality reduction with the help of kernel, right? So we can try to do that. So as of now, I have not discussed PCA, so I'll not go into that topic, but yeah, it is possible. And after PCA, I believe you will take 1,000, you will take a data set with 1,000 columns. I'm not talking about rows, 1,000 columns, and you will be able to visualize even a shape of 1,000 data set, 1,000 dimensional data set. You will be able to visualize it any dimension, simple, n dimension, right? Curse of dimension. No, it's not a correct word. It's been used in a different sense. Okay. So yeah, by that you will be able to visualize it. So don't worry, even if it is a 2D or 3D or even 10D or 100D, it is possible to visualize it. Yeah. Okay. So DBSCAN is working well with the spherical one. We are able to understand. Now let's talk about this kind of a data set. Which one is working best? So can I say that agglomerative, ward, this is working well, right? Yeah, this one is working well. This is not 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 working well, right? So with this kind of a data set, again, so which algorithm you will choose? So which algorithm you know as of now? I think DBSCAN is the only one that you know, apart from that agglomerative. So either you can use agglomerative or you can use DBSCAN for this kind of a data set. The people who was asking me that which one I'm supposed to use with what, I'm just giving you that answer, right, in detailed way. Now here, if I have a scattered data set, now tell me which one is working well. So see, this one is not helping you out to find out the outliers, right? But here, all these black dots are nothing but it's outliers, right? This is trying to find out outliers, but again, it's an excessive one. Unnecessarily, it is trying to create or consider these points as outliers where it is not supposed to consider it, right? So in this kind of a scattered data set, which will be your best algorithm? Which algorithm you will choose? Again, DBSCAN you will choose. I told you, right? DBSCAN is one of the best one, right? I'm just trying to prove that point, nothing else. So you will choose DBSCAN. Now, this data set, if I'm going to consider, then which one you are going to choose out of your known algorithm, right? This is not able to separate. See, it's mixing, right? It's mixing. Can I say that here it is able to separate very clearly, right? So can I say that again, I'll try to choose this one. Yes. So I'll try to choose this one, right? This is a very simple one. So any algorithm can work in this one. So clear separations that we are able to see. So DBSCAN or here k-mean clustering, I can try to use. So now you are able to get an answer. So in which case we are supposed to use k-mean, where we have a very, very clear separation. Aap DBSCAN promote kar rahe hain. Yeah, it's a good one. So I've used it many times regularly. So that's the reason. So I keep on saying, go ahead with DBSCAN. Even if you are not aware about database, like a set of shape of the data set, go ahead with that. It will not fail at least, right? So can I say that with this one, with the simple data set where separation is very clear, even k-mean is working well, right? And even DBSCAN is working well. So it's completely fine. Whether it's a DBSCAN and C, you can use AD because clear separation is visible in this particular place, right? Now with these data sets, which one I'm supposed to use? This one, which one I'm supposed to use? The last one. Again, can I say DBSCAN? Because see, this is the part of same data, same like a say, right? Data set is like a dense and there is no variations you are able to find out. So why to divide unnecessarily? Just for the sake of dividing it, right? So we are not supposed to divide it, right? Unless and until it's not required, it's not important. Unnecessarily k-mean clustering is dividing it. No, someone is saying k-mean. Why we are going to use k-mean, right? So this is a complete like a congested data set. This is the completely compact data set. We have a completely dense data set. So do we require a division over here? Do we require a division over here? No, right? Right? We don't need it. But here we are like creating free clusters unnecessarily. Why? It's not required. So this is actually wrong. You are creating a cluster, that's true, but you're not supposed to do it. Nature of the data set says that no, you're not supposed to create it. So why you're creating it, right? No. Let's talk about DBSCAN. Can I say that I'm able to get a better result? It is not dividing. So DBSCAN 5 out of 5, k-mean 1 out of 5. So I'm saying, yeah. So can I say that again my answer will be DBSCAN? Yes. Okay. Now agglomerative over a DBSCAN. So here you will be able to find out a benchmark timing as well. So when sklearn people, these people have tested it, right? So they have created a benchmark. So let's suppose I'll just give you answer as well. So when Agglo and when DBSCAN. So can I say that even this one is like creating a proper cluster and even this one is creating a proper cluster? Both is working fine. Yeah, both is working fine, right? DBSCAN and agglomerative clustering, both is fine for me, right? In this case, if I'll give you these two options, choose agglomerative and a DBSCAN, out of which one you will choose and why you will choose? Can I say that timing is very, very less, so it's less complex, right? Time complexity for this algorithm is very less as compared to a time complexity of this one. So again, we have a very clear separations. It's taking almost 1/6 time. So I'll try to choose those algorithm which is taking less amount of time for me, right? So I think again we have our answer over here, right? So that is the reason I always try to showcase this particular picture to all of my learners, so that you will be able to get a very clear understanding. And yeah, so when you're going for the interview, so if someone is going to ask you a question like this one is given, this one is given, then which one? So maybe based on the time, based on the accuracy, right? So you will be able to give your answer, and DBS scan wins. Simple. Yeah. What about Gaussian mixture? Gaussian mixture is not a good one. So it's like a better not to talk about it. And again, it's a very simple one. If you'll go and study, right? So you will be able to find out like a Gaussian mixture model is not good as compared to a DBS scan. So you're not supposed to know all of these things. I believe you should know whatever is required. Optics also seems better. Yeah, it seems better just in terms of accuracy, but just compare a time. It's more than 100 times, right? So it's even costlier than your agglomerative clustering. So why I will choose optics? I'll go ahead with the agglomerative in that case, if that is an option which is given to me. So optics is fine, but check its timestamp that it is taking. It's very, very high. So time complexity is too high. And someone was saying me, right, telling me that I think it was Achat, that he was trying to do like a fine tuning of the hyperparameter, and in last 3 hours he was not able to do it. So yeah, that will happen with you in that case. You will deploy your solution and your entire server will crash. Your server will not be able to take a load of it, right? So you don't want that kind of algorithm again. Okay. So that's the reason optics is not going to be your choice, although it is giving you a accuracy. But we have to think about our complexities as well. Is there any way of knowing a time complexity of ML algo? Yes, it is a way. And it's very simple way I'm going to tell you, right? And maybe probably you are going to laugh. So when you are going to call a fit method, right? So just before that, try to call OS timestamp, right? Start time, and then after OS timestamp, right? Because see, if your data set is going to change, so see, this not like OS ML algorithm complexity. It depends actually upon a data set, right? Let's suppose I'm trying to form a decision tree with two different data sets. So one will be like a big, one will be a little bit small. So in one, more calculation will be involved in terms of Gini or information gain. In other, less will be involved. So it's always compared in terms of a data set. What is the volume of the data set you are going to send? Is it fine? Yeah, so I think Rohit was asking this question. So Rohit, is fine for you? These are only for classification problem. No, Anurava, I'm talking about a clustering problem. I'm not talking about a classification or maybe a regression. I'm talking about a third kind of a problem statement. I think you have joined class maybe a little bit late. So I have started with an unsupervised approach. I'm talking about unsupervised approach as of now. So hope guys, your answer, you are able to get an answer, which one I'm supposed to use when, right? So just whenever you have a confusion, open up official like a image official diagram from scikit-learn itself, right? You will be having your answer. Very simple, right? Can we cluster text data set? Yes, easily, right? Easily we can try to do it, and you will be doing it in a class itself. Did you already cover SVM? Yes, we have already covered SVM. People are using it. Can you please explain why WCSS decreases when K value increased? Okay. So why WCSS? Okay, fine. Let me just take this question. Yeah. So person is asking that why WCSS decreases when K value is going to increase. Okay. So K 1, 2, 3, 4, 5, 6, and so on, right? And this is representing WCSS or maybe inertia. Okay, either of these. And this is representing K values. Now let's suppose I have a data points, right? I have a data points. So let's suppose if I'm trying to build n number of cluster, what will happen? So what will happen to WCSS? So can I say if number of cluster is equal to number of data points, right? So what will be a distance of this points and its centroid? 0, right? It's going to be 0 for sure, right? So what will be a summation of this entire, like a WCSS summation of a square? Can I say it's 0? So when number of points means, let's suppose somewhere over here, right? Number of points is equal to the number of cluster, it will tend to 0, right? Let's suppose if I'm going to create only one cluster. This is the centroid. So distance, this 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 one, and this one, right? Sorry, this one, right? So here in this case, can I say that I will be having a maximum distances, because if I'm going to divide this data in 2 cluster, right? Let's suppose, okay, it's like a taking like a auto things. Yeah. So let's suppose if, okay, again, like, let me switch off this one. There was option over here where I can switch off auto detection. I don't remember where I was able to find out, but let's see. Pen switch, so bar, right on pen, right pan off. Okay. So maybe this time it is not. Okay, it's working. Yeah, I have to switch off my auto detection here. So black pen off, bottom digital pen. No. Okay, fine, forget about it. It's a feature. So let's suppose I have created a cluster over here, right? I'm just trying to create a cluster over here. There's 3 clusters. So can I say that centroid will be here, centroid will be here, and centroid will be here? Now, this distance, this distance, this distance, summation of, and then all 3. So can I say that this will be lesser than this one? Yes. Yeah. So when I have only one cluster, it will be maximum. Then if I'm trying to increase the cluster, again, it will decrease. Distance will keep on decreasing. And when I have a number of clusters is equal to number of points, it will keep on decreasing. So it's a very simple calculations. So hope you are able to get the answer. Is this a distance Euclidean distances? Yes, I'm talking about Euclidean distances. Yes. Atul is asking that in DBSCAN, if data points is exceeding its own new cluster. Okay, in DBSCAN, if data points is exceeding its own new cluster, then it is considered as a new cluster or extended part of the original cluster. No, if data points is not a part of any other cluster, then it will be a part of the current cluster. Is batched k-mean better than k-mean itself? Mini batch, actually. Yeah, it's called as mini batch. So yes, it's proven that mini batch is a little bit better as compared to a k-mean. Again, algorithm wise, it's not very different. So in case of a mini batch, what we do is, let's suppose I have 100 number of records, right? Let's suppose I have 100 number of records. I'll not send all the data. I'll try to create a batches. Let's suppose I'll try to create a batches. First of all, I'll send this batch, then I'll try to send second batches. This is something called as a batch k-mean. So cluster act as a feature as well as a label. So I'll show you that, because again that creates a confusion. So I'll show you that one, that when we try to create a cluster, it's possible to generate a label of each and every data set, that this data set belongs to which cluster, right? And that will give you a very clear understanding that, okay, how we can try to use these things for even for the labeling purposes, right? Yeah, so that is possible. Can data in batches overlap? No, it's like a mini batch if I'm talking about. So maybe distinct batch we try to create. If there are 100 data point in that, how there will be a vertical line drawn? 100 data point, then how will the vertical line be drawn? I'm not able to get your question. So Srikant, in what context you are asking your questions? it will be very fast in outlier detection. Yeah, DBS scan is. Higher clustering dendrogram, please explain one more time. See, this dendrogram is not tough to understand. So I had like a multiple points over here. So we are trying to keep it in this particular place. In this is just arrangement. So don't get confused. This is just arrangement that we are trying to make over here, right? And after making this kind of arrangement, so what we are trying to do is, so we are trying to find out that, okay, so between this and this point, what is a similarity? Between this point and this point, what is a similarity? Maybe based on the equilibrium distances, maybe based on the different kind of a any kind of a intuition I can try to take, and based on that I can try to search for the similarity. So once I will be able to search for the similarity, I'll just connect. So two points, I'll keep on connecting. Then again, I'll try to check the similarity, I'll try to connect it. And in this way, I'll keep on doing this repetitive process unless and until I'm not able to connect all the data set. And then from the mean, I'll try to draw a line. Based on mean, vertical line will be drawn. Yes, that's true. So based on the average of this entire range, so this will be drawn. So maybe you can say middle point. DBS scan is only unsupervised algo that identifies outlier as a noise. Yes, in general, that's true. But yeah, if you'll just go and check this figure, right? So even this optics is helping you out to find out the outliers, right? But time complexity is very high, so it's not advisable to use this optics. And again, it's not better than DBS scan. So to be on safer side, DBS scan is the best. What if point is overlapped between two clusters? It is not going to happen, right? I already told you that if some points is already considered as a part of some of the cluster, in that case, another cluster is not going to consider it. Now, what is linkage? Linkage is nothing but so there is something called as a ward linkage. There is something called as average linkage. There is something called as complete linkage. There is something called as a single linkage. So this linkage is nothing but it always defines that how you are trying to connect, right? How you're trying to connect one cluster with the another one. So maybe with the help of centroid linkage, I'm considering a centroid point. Maybe with the help of single linkage, so single points I'm trying to consider. Maybe average linkage, so average of this points I'm trying to consider. So that is called as a linkage. Okay. Now in the question, so hyperparameter tuning. So hyperparameter tuning wise, you can try to select a range of the values, and then you can try to like test it with the accuracy. Can we drop a noise point in a DBS scan? Yes, indeed. That's the reason. So we are using a DBS scan. So it is possible to label all the data, all the rows that will be a noise point or that is a part of some cluster. So if some data set, which I'll show you tomorrow anyhow, right? So it is like a possible. Now maybe we can try to talk about accuracy. So this is again a very important point. How we can try to find out or evaluate a clustering algorithm. Regression, we know about it. Classification, we already know about it. But how we can try to ML Cup finish hoga. Probably by next week it will be finished, right? Because I have to discuss, I believe, naive based algorithm. I have to discuss like a time series. I have to discuss naive bias from your like a classification side, and time series I have to discuss. Anomaly detection algorithm I have to discuss. So I believe only 3 algorithm is left, right? Okay, PCA is one of the important one. PCA will take like so much of time. So PCA, XGBoost, I have to like talk about some ads on top of the XGBoost. And implementation wise, so I think stacking we have completed. So complete implementation of this clustering algorithm plus whatever algorithm that we are going to learn. So most probably by polynomial regression, I think you should like learn it by yourself by this time. You're not supposed to wait for like a polynomial at least. When I've already discussed about these things in detail, even in my previous recording, polynomials are available. So this time in your class, I have not discussed, but in my previous classes, it was like already available. So yeah, you have to give an explanation of algorithm without giving an exact formula, only theory part. See, Swam. So if you know about the formula, it always gives you points, right? And with the help of that point, so I think you will be able to like explain in a better way. So I never recommend anyone to just like remember maybe a theoretical things, because when you explain something with a formula, it always creates a different kind of impression. And just wait a minute, guys. So data science. Yeah. So I'm just going to like ping you. Gradient descent, I believe I have already discussed when I was talking about your linear regression, and again gradient descent will be discussed in your deep learning section. So in again like very detailed. So that is already there. No, not this one. Okay. So guys, I have like this one for you. So I have a task for you, right? So and try to complete it before tomorrow's class. I think that will be better, right? Because here you're just supposed to like you will end up revising each and everything. So I'm going to share two set with all of you, right? Interview question set one and interview question set number two, which I have recently prepared in my interview classes. Right. So data science interview preparation classes, I have already prepared it. Plus, I have a company-wise interview questions as well, which you can try to touch maybe in a later stage, right? And I believe if you will start looking into this question, so now you are in position to answer these questions. So what do you understand by feature selection? What is the effect of coefficient of logistic regression if two, three beta are highly correlated? What is the confidence interval of the coefficient? What is the difference between Gaussian mixture model and K-means? How do you pick K for K mean? Right, today we have discussed how do you know when Gaussian mixture model is applicable. So I think we were able to find out this answer today itself, the Gaussian mixture model. Right, this is a Gaussian mixture model, right? So yeah, although it's like a efficient one, right? Efficient one, but not very good in terms of a complex data set. It's very good in terms of like a simple data set. So these are the kind of questions which will be asked. People are not crossing these labels. Do you know how to use Amazon SageMaker for ML ops? So I believe I have already given you ML flow and DVC challenges, right? What is VIF? I think you will be able to explain. What is log loss, ROC, AUC? What is multicollinearity, right? So most of the question, I believe you will be able to attempt based on our discussions that we have done. Verizon, so these are the questions that they have asked. So how many cars there in Chennai? It's just like a logical, like a question. Multilinear regression, OLS versus MLE, R2 versus adjusted R2, lift chart, drift chart, sigmoid function logistics, sigmoid, ROC versus ROC, what it is, AUC, and differentiation. So most of the questions you all will be able to answer, even company wise. But you are not supposed to touch these questions as of now, because from multiple companies, these are the questions which was asked recently. And my student has prepared it and they have shared with me, right? So task for you is, so just try to like prepare an answer, right? And then those questions will be covered automatically, right? So just try to prepare your own version of answer. No Google search is required, not even a single line you are supposed to copy and paste from a Google search. It's better not to do it, right? At least this one, right? It's better not to do it instead of like googling, or instead of like a copy and pasting from a Google. Yes, you can go take a references, read out some articles, read out books, whatever, do a googling for an understanding purpose, for a revision purpose, revisit your class lecture, revisit your class material. There is no issue, right? But question answer wise, try to write your own version and try to check how many questions you are able to answer and you are able to explain in your word. That is a meaning of this homework, right? I'm not expecting this like write-ups or maybe like solutions from your side. I already have a solution, so even in a later stage I will be able to share this solution, because whatever questions which I'm giving you, so for that question, so we have already prepared our own version of a solution for every question. I know solution is already there, right? Same questions, all the solutions are already with me. We have already written all the answers from our side. Our team has written this entire like answers, right? And that we have discussed in our 30 days interview questions as well for the same questions, right? But for you, yeah, so you are not supposed to take your time, right? There is no issue, but what I'm expecting from your side is you should write an answer by yourself. If you're not able to answer, that's fine, do a search, right? Try to understand, try to revise, because there is nothing, what I believe is there is nothing that we have not discussed so far so forth. More 99% plus of the things we have already discussed, right? A task which I'm going to give you from ML side, in terms of a theoretical. So theoretically, it will try to build you. This is just a cover your theoretical part, not a project part. Yeah. So I'm just like trying to cover, and I'm just giving you a point so that you will be able to revise, because it's been a long time since we have discussed stats, since we have discussed multiple like ML algorithms and all such kind of things. So set number one, I believe you are supposed to do each and everything. Just try to answer each and every question. In set number two, so maybe you can try to answer before deep learning. So whatever question you think that it's from a deep learning, just leave it, right? Don't come and ask that whether I should answer this question or not. If you're able to answer, answer it. If you're not able to answer, it is from a deep learning part, just leave it, right? I don't have any issue with that. But you are going to answer, let's suppose, maybe only 10 questions, right? I'm okay with it. I don't have any kind of an issue. If you are going to answer honestly only 10 questions instead of completing all the questions, right, by doing some sort of copy paste. So it's just for your revision purpose. That is the reason I'm giving you this particular task. And I'm assuming that you all will take this task seriously, and you will start working on these particular tasks honestly. So in set number two, right, so maybe you can try to answer as much as possible, right? So most of the questions you will be able to answer from wherever you will see that there is a neural network based question, just leave it, leave everything after that, because after that, so I have given just back to back this neural network based question itself. So just try to leave it. Even my recorded version of explanation is available in my 30 days interview questions, but once you will be able to cover these things, I think you don't need it. So it's completely fine. And what I believe is you are aware about these entire things. So just I'll share this Google Drive link where these questions are available with all of you. Yeah. So this is a Google Drive link. Same link, I'll make sure that it will be available even inside your dashboard, right? Within a 24-hour of your class. By then, I think even now I'll ask my team to it will be available, right? So just try to prepare. I'm not expecting any copy paste over here. If you're not able to do it, take your time, right? Take your time, sit peacefully, and then try to do it. And try to write all of those answer in blog.in, right? So it's a simple portal that we have, and maybe in the beginning we told you that okay, you are going to write something, articles or something, right? So many people used to write so many articles, so many things over here. So what you can do is maybe you can try to create, you can try to write maybe a set of 10 questions in one article with it's like a, and it's very easy to write over here, right? So keep on posting, it will be published on your name, right? You can try to share, you can try to use it even for the future references, your own version, and even other person. So let's suppose same question is been answered by a 10 person, 10 different people, so even other people will be able to see your version, right? If they have made some sort of a mistake, so they will be able to rectify it, or they will be able to utilize it in their future. And even in future, so when there will be a one-to-one or maybe a P2P discussions, which we are going to initiate, so you can try to take this one and then you can start discussing about it. And it will create a very good revision points as well, right? So a simple thing is, if you are able to answer only 10, just answer only 10, but don't rush it up and don't like a try to unnecessarily do a copy and paste. We can collaborate with the medium, so it's fine. Like just try to post it over there. Maybe in a later stage you can try to post it over a medium. We have Iron account on a medium, but that we can't share with everyone, so that's the reason we have created our own platform. And send me this link. So whenever you are going to complete maybe 10 questions, set of 10, so don't try to put up everything in the single one. So maybe you can try to keep like a 10, or maybe for an individual question, if you are going to maybe record your explanation, so you can do that. Even there is a feature that inside the article, you can try to embed those recording links, whatever you feel. I'm leaving this up to you, but try to answer these questions in a best possible way with your best version. And plus, try to convince yourself. You're not supposed to convince others that my question or my answer or my way of explanation is good or bad, right? You have to convince yourself that, okay, fine, so yes, this is a perfect answer, right? And then try to check others answer as well, which we are going to do. So if everything will be available over here, even it will be easier for me to share these links with all of you, so that all of you will be able to read out each and everyone's version. The whole ideology over here is revise all of these interview questions n number of times, so that everything will be on your fingertips. That's the whole idea over here. Yes, this is the same set which is available in our dashboard. Yeah, it's the same set which is available in your dashboard, but I believe you have not even looked into it, right? So far, so forth. And I was just waiting for this time that, okay, so after some time, like I'll give you these things as a task. Yeah. Is there any word limit for answer? No. See, explanation wise, whether you are going to give a video explanation, you are going to type it, you are going to use some giphy, maybe some sort of images you are going to draw, and then you are going to explain. I don't have any issue, because every person is having a different explanation capability. The way everyone's understand is different. Your neural network is different, right? For sure. So in your own way, you have to explain. But the idea is everything should be on your fingertips. When you're going for the interview, you should not like say that, okay, so I have studied these things, but I'm sorry, I'm not able to recall it, right? This happens, and this happens always with the freshers, right? Or people who are trying to get into this industry for the very first time. So at least from a theoretical side, you will be secured. And anyhow, we are moving towards a project side. So from project side, we'll be secured. From a theoretical side, we'll be secured for ML stats and this Python part, right? So we will be ready for an interview. I have submitted once using a Google form. It's great. So just try to do it over here. So I completed all 3 sets, helps a lot to get many offers. Yes, Subham. So see, I told you, right? This is something which is going to help you out directly, not indirectly. I'm asking you, right? And believe me, even your interviewer, so most of the time you'll feel like your interviewer, your director, your managers are from Iron, and the way you are going to answer, they will instantly tell you that, okay, fine, so you are the student of Iron. This happens very frequently nowadays. So yeah, so this happens very frequently, believe me, right? And even they ask questions from this set itself. So it's better to clear it, so that theoretical part will be closed, mathematical explanation will be closed, and then major thing is project, right? Because project is something which you're going to write in your resume. Project is something which people will discuss in a very first place, and then they will come to this theoretical part. So anyhow, project will try to close. But yeah, so parallelly, I don't want you to forget anything that we have discussed. So is it fine? So can I get some like a commitment from your side for a consistent effort, unless and until you're not going to publish all of these answers. So how to prepare for the big data? First prepare for this one and then go for that. Yeah. So just see, whenever you are free, right? Write one, post it. It's not like all the time you're supposed to like complete all these things at a time. No, it's not required, right? Write one, write two. So I need to revise a statistic concept from your recording, sir. It's fine. Just go ahead with the questions and then try to understand, right? It's kind of a reverse engineering. I'll complete all the answers by next Saturday. That's great, Sridhar. So I'm expecting a link from your side then. Yeah, and I'll share this link with all of like us, so that everyone will visit and read out your answers. Whatever we'll do, we'll post. Not whatever means like a meaningful things you have to do. I have to revise stats, but I promise you will do it one by one. At least keep a target that okay, daily 5, 10, 5, 10. This is the target I think you should keep. It will not take much time, right? Just half an hour, maybe before going to your bed, so you can just do it. Yeah. Can we upload any images that will made a graphs on our hand notebook? Yeah, that is possible. Images you can embed a Giphy, you can embed any YouTube. So every feature is there. All these features are already available in blog. You can just like use it, but make sure that we are going to close theoretical side of ML, right? And then a practical side of ML. Okay, so what about grammatical error? My English is not best, that's why I'm asking. So in that case, you can maybe write down first of all in a Word document. Even mine is not that great, so I generally do that. I sometimes use a Grammarly as well. So I have installed already Grammarly in my system. Or you can try to use a WordPad, write your answer, and then it will automatically give you those errors, right? Right click, correct it, and then publish it. So there is a way, right? Going forward you can use NLP libraries, so even that is a like a this. Yeah, Grammarly is the best one, I believe. So Grammarly you can use it. We can write that in a resume that we have contributed some article in an blog. Exactly, yes, you can directly do these things and you can showcase that. Okay, fine, so in my part-time, so this is the link, and go and check, and when they will see a quality, right, that okay, fine, so this person is very knowledgeable. So let's suppose you have published all the answers, right, and your interviewer is looking into, you have pasted those links into a resume. Your interviewer will see, okay, fine, this answer is given by this guy, right? What they will ask beyond that? It's not possible to ask any other questions, right? They themselves will be able to understand that, okay, so nothing is left to ask, so they will just close. So this things happens actually, right? Got a mail for Einar vacancy. Yeah, one more announcement, guys. Yeah. So we have a vacancy. We are hiring a technical consultant in our team. Freshers, degree and your certificates is not a barrier. There are more than 80 plus positions which is available with iNeuron, which we have a target to hire between. We have already started hiring like 4 to 5 people. We have already onboarded this month itself. So 80 people is a total like a number or a strength that we are like trying to onboard 80 more apart from this existing team. And yes, so I believe you have received a mail, because purposely I have asked my team to send a mail to your batch plus my email batch plus my DL batches and all those batches, right? So yeah, if you are okay, you can try to participate. And package wise, so as of now we are giving 4.2 for a fresher. So I think which is good. And if you have some exceptional capability, there is no barricade, there is no limit. Just have to prove. Simple, right? But yeah, so no degree is required. No certification is required. Gap doesn't matter. All those things means all those norms doesn't matter for us. Simple when we are hiring, right? So yeah, this is for fresher. Yeah, this is for fresher. For experienced person, so I think inside iNeuron there will be an opportunity maybe in like a future. Even you have a 2-3 year of experience, you can just apply for that, right? And soon we are going to run your like resume preparation as well, because even we have so many openings from other companies, so many that I'm not able to provide a resume, right? There is a kind of order that I have received from other companies, so we are sending people, right? So yeah, just be ready. So that's the reason. So I'm just trying to like discuss first of all project, so that at least your resume will be ready. and we'll start sending your resume to our associates and our associate companies. Those are going to pay you even better than Iron maybe. Yeah, much better than like Iron. They're going to pay you. I'm a third year. Can I apply for Iron job? No, because you are supposed to come to Bangalore. You are supposed to sit in Bangalore office and then you have to work. No work from home options. Can we get an opportunity for someone with the 25 plus year of experiences? Yeah, we have a couple of positions, even for a very senior positions. Even today, I was discussing about these opportunities with some of the associates and some of the persons. So you can just prepare it, and yeah. So we have that one, not with iKnow. I'm talking about with other companies. What if you want to start my career with iron only? Yeah, just do it. I don't have any issue. See, we always respect our talent. That's the reason. So we have removed this barricade of certificate, degree, or your gap and all those things, right? Because talent is different, and the certification and degree and all those things is different. I don't believe personally in those things. So I don't have any issue. We have openings. We have sent you a form. My team is doing interview on a daily basis. I think they are taking an interview of 25 people, right? So yeah, just apply and then test yourself, right? At least you will end up getting that. You will end up knowing that, okay, fine, so where is an issue, right? So is teaching over for today? Yeah, at least for today it's over. Tomorrow I'm going to talk about validation matrices for a clustering. So where there are so many things I have to discuss, like a Jaccardine coefficient, brand indexes, and again entropy, purity, cohesion, separations. So there are so many matrices. I have just completed till EDA part. Don't come and tell me I have completed EDA part. No one, it's having no values actually, zero. you Wednesday, yes, I had interview on Wednesday in Iron for BA position. Okay, Gaurav, yeah. So my team is just doing it, so they will respond. I don't take an interview, so don't worry. I'm not going to take even an interview of single person, not even in your final round. So I don't take that. Otherwise, it will be a biased one, right? So I don't take interview. In Iron, especially. And you will feel like I am grilling you. So yeah, Soham is saying that you will grill us. So that's the reason. So I never take interview. I just take interview over a YouTube channel. So if you are willing to come, please come. I have just done one project. I'm eligible for an interview. Submit your resume. My team will decide, right? If you are fit, then they will give you a call. Because anyhow they are calling. They are calling everyone, and then we are taking interview. We know how your question will be. I saw YouTube. Yeah, next time question will be different. It depends upon just your resume. What you are going to write in your resume. My question just depends upon you. It doesn't depend upon me. Can companies ask implement machine learning algorithm in Python rather than using sklearn? No, this kind of a things they will never ask. No one does that, right? So don't worry. When will this recording be uploaded? Can you please confirm missed first hour of session due to internet issue? Our timeline is 24 hours, but by tonight it will be available. It takes time, so it will. But yeah, it will be available anyhow. I'm learning everything from this course only. I'm good with the advanced Excel, SQL, Power BI, and then apply. So not a pro, apply for it. See, we are not even expecting pro level. It's not like we are hiring freshers, so we'll be expecting that no, you should know each and everything. This is not an expectation, right? We can't keep this kind of expectation. But if you have an understanding, this is so we always try to check your understanding and your capability to adopt, right? These are the first instructions that we have circulated inside our team, that whenever we are taking an interview, so it's not like we are supposed to ask something which is not required, or where we are facing an issue and we should ask you the same thing. No, we just try to check your capabilities, how good you are in terms of understanding things and in terms of doing an implementation, and how honest you are. So this is the criteria that we try to check. Does companies ask mathematical derivation? Generally, no, but with algorithmic explanation, if you can include a mathematical derivations and mathematical explanation, that always creates wow, and then always that gives you a kind of a weightage. So I think it's good to have that. Sir, are freshers not considered for 2-3 experience profile in job market? Yes, it's considered, but depends companies to companies, not same for all. Yesterday, one of the companies had asked me how much mental stress you can take in the job. Anuj is asking. So just tell them like I can work 24 into 7 is 365. Simple. बोलने में क्या जाता है? Later stage you can manage. Yeah, mental health comes first, but it's not like no one is going to ask you for 24 into 7 into 365, right? And it's just like kind of a converse. It's just a part of conversation. That's it. So just take it in that way. Don't take it seriously. I got an offer for permanent work from home. Yeah, that's good. But again, companies to companies, we have our different policies, right? So that varies companies to companies. Okay, sir, once discuss about the projectathon. Okay, yeah, projectathon. So fine, guys. I think many of you are participating, right? Already in a internship, right? All of you are doing like auto neuro projects as well. So here is exciting news for all of you, and this is created by Avnis. Avnis is the same guy who won a projectathon last time, right? And he won a prize money as a laptop. Plus, he was able to like join iNeedon as well with 300% hike. I think you all are aware about it, and I think videos and everything is available on my channel. Right now, it's the same person who have set this problem statement this time, right? For our next projectathon, where this has already started from 21st October. Chris has already made a video, so you can check a detail. And I believe for my full stack batch, this is not a big deal. What I believe is a kind of a work that you are doing and the kind of a discussions that we will end up doing in next 2 to 3 weeks, you can utilize those work over here and then you can participate easily. This is what I'm assuming. So again, you guys can like prove it or disapprove it. But this is what I'm assuming, that my full stack batch people can participate over here, and there is a prize that we have given. This things is this challenge available in your same internship dashboard under a projectathon as a tech, then ML, and then inside that, this one you will be able to find out. Prize money is 2 lakh, 1 lakh, 2 lakh, 1.5 lakh, 1 lakh, 50,000, 25,000. You can work or deliver this project as an individual, or you can try to deliver maybe in a group, because that option is already available inside your internship dashboard, right? Criteria, I think most of you are aware about it. Read out the problem statement, what we are expecting. Data set link we have already given to you. It's a kind of a system implementation that we are looking for, right? So just try to participate. And yes, so your clock is ticking, so fine. Last date for this submission is 23rd November. So how many of you are participating? जब तक पागल नहीं कर दोगे तब तक handle हो जाएगा mental. Yeah, exactly. This is what we are supposed to. Mukesh is saying, okay, Manjunath is participating. Just even knocking for data, I'm getting a lot of call based on my total year of experience as soon as they know that I am doing an internship right now. So talk ends there. So don't say right. Don't say that like you are doing internship as of now. Don't mention those things. Why are you mentioning? No. Yeah, so anyone else who is participating? So Subham, Manjunath, Mukesh is participating. Jairam, I'm working on ML internship, so I'll not participate. Try to participate, maybe 10%, 20%, right? Time nahi hai semester chalo, but participate to bilkul karenge. Yeah. So just try to participate. What to say then? So like, are you just doing an internship because you said that you have like a total year of experience, right, Anup? So 7 year. Yeah, so just maybe schedule your resume discussion with us, and then try to understand how to talk about your this one 7 year of experience. I think okay, right now you're not okay. Okay. So okay, let's do one thing. Come to this Monday's discussion, we'll discuss. Yeah, let's come over here, we'll discuss, and we'll try to like tell you that what should be the version from your side. I'll try to understand your situation as well. Relevant, that will be good. Yeah. So fine, guys, participate. I think so many things is there in your plate. Please try to do it slowly. Don't try to like take so much of a stress. It's a festive season, so take rest, take care of yourself. Plus, slowly and gradually, just in a progressive way, keep on adding something new. plus soon we have to prepare our resume, because those who are not able to, many of you are already able to get a job, right, in your batch itself. Those who are not, it's my responsibility to push you harder and harder, so that no one will be left out by March or April. We have already given you 12 months plus 9 months, but I'm not even counting those 9 months. I'm just counting this 12 months. That's it, for this placement and everything. So that's my target. I'm not on any project, so wondering what project details to write in my resume. Okay, no issue. So anyhow, project I'm going to discuss right very soon. My team will even participate in those project discussion. They will help you out a lot in the project discussion. So yeah, I'm already pushing myself harder so that I can get a job. No issue, Anup. So yeah, it's fine. You can even try out with Ainuron. So with us, right? So maybe I'll like schedule these things. Well, mentorship will be provided on Project Hackathon? No, it's a hackathon. There is no mentorship. There is no guidance. It's a prize money, right? Associated with it. So there is no guidance. Why do you need guidance? So I think you can do it. This is what I believe, right? Yeah, it's tough. There is no doubt, but people have done that, right? We have a person who has done that, who has proven it, right? So even you can do it, right? Okay, so when project discussion will start? I believe after 2 weeks, your project discussion is going to start, right? Because in between those times, max to max, I'll take another 5 classes where I will end up wrapping up like this entire things. So your project discussion is going to start very soon for ML and your Python project that we have left out. So all ML, all Python, this will start with ML flow, DVC, retraining, right? Deployment, production, everything will come over here itself at a time in all the projects. Developer roles, same as a data analyst. Yeah, that's same. I think. CV is not very disordered with the prepare the CV. Yeah, so you can schedule these things with our team. So I think they are helping you out. They have already like told that okay, we are going to help. So for sure you can raise your request and then that will be like taken care of from our side. So fine guys, thank you so much. See you again tomorrow, same time, 3 p.m. IST. And tomorrow I'll try to start from the same place where I'm leaving as of now, like evaluation matrices for clustering, then a couple of theoretical things. Then if time allows, we'll see practical back to back. Pressure, should I focus DSA aptitude a little bit? Sure, yeah. Thank you guys. Take care. Thanks everyone. Thank you.